FKIP Universitas Jember pada saat ini mengelola 12 program studi S1 tingkat sarjana dan 3 program studi S2 tingkat magister. 12 program studi tingkat sarjana diantaranya adalah program studi pendidikan matematika, program studi pendidikan fisika, program studi pendidikan biologi. Kemudian
pembuatan gedung H, diantaranya di dalamnya ada auditorium yang cukup indah ya. Saya juga membuat tempat-tempat belajar di taman di tengah tadi. Selain saya bangun taman, juga tempat-tempat belajar ya, sehingga sudah ada meja-meja banyak sekali yang permanen ya, sehingga wifi juga saya tambah sehingga semuanya mahasiswa lebih nyaman sekali sekarang belajar di FKIP. Saya juga membuat panggung pentas yang spektakuler ya, sehingga sudah bisa untuk melampiaskan bakat minat mahasiswa. Kemudian pembuatan lapangan basket, kemudian saya tambah pembuatan lapangan bulu tangkis, kemudian sekarang juga saya buat lapangan tenis, dan nanti juga bisa untuk lapangan olahraga bersama. Sehingga tujuan saya untuk hanya mengembangkan FKIP semakin maju dan jaya FKIP.
Untuk bidang akademik, kami mengembangkan program terutama yaitu program penalaran dan juga program keilmuan, yang salah satunya adalah bidang Olimpiade ONMIPA atau Olimpiade bidang studi yang lainnya. Sementara untuk bidang yang non-akademik, melalui kegiatan UKM, kami juga mengembangkan bidang-bidang bakat dan minat mahasiswa, terutama dalam hal ini adalah bakat minat mahasiswa dalam bidang seni, dalam bidang olahraga, maupun dalam bidang keterampilan-keterampilan yang lainnya. Ada 22 UKM yang ada di FKIP Universitas Jember, di mana ada 10 HMP dan ada 12 UKM yang ada di FKIP, yang semuanya itu adalah sebagai media atau sebagai wadah untuk pengembangan minat dan bakat bagi adik-adik mahasiswa FKIP Universitas Jember. Kami juga mengadakan perlombaan-perlombaan baik di tingkat fakultas maupun lomba-lomba yang kita ikuti dalam tingkat universitas maupun tingkat lintas universitas, bahkan sampai pada tingkat regional dan tingkat nasional. Akan tapi sebelum mereka mengikuti lomba, biasanya kita lakukan dulu yaitu pembinaan-pembinaan, pendampingan-pendampingan. Mudah-mudahan mahasiswa-mahasiswa FKIP terus berkembang, terus menuju pada puncak prestasi, dan itu semua bisa dijadikan sebagai media untuk menuju kesuksesan di masa-masa yang akan datang. Terima kasih.
Pada dasarnya perkuliahan itu tidak hanya terkait dengan pembelajaran di kelas, namun dengan adanya unit kegiatan mahasiswa, di sini dapat mengembangkan soft skill dan dapat melatih bakat dan minat seluruh mahasiswa FKIP.
Di FKIP Universitas Jember ada program yang diselenggarakan oleh IDB, salah satunya adalah kredit transfer. Jadi kredit transfer ini adalah program pertukaran mahasiswa dari Universitas Jember ke universitas lain. Jadi yang saya ambil di sini itu adalah program untuk bimbingan skripsi saya 6 SKS. Jadi di situ saya bukan hanya dibimbing oleh dosen dari Universitas Jember, tapi juga dari universitas lain itu. Jadi semua biaya untuk tinggal di sana, untuk bimbingan juga semuanya udah dibiayai oleh IDB. Jadi seperti itu program IDB.
Pekan Ilmiah Mahasiswa Nasional atau PIMNAS merupakan event terbesar mahasiswa yang diselenggarakan setiap tahunnya oleh Kemenristek Dikti. Tahun ini, alhamdulillah, FKIP mewakili Universitas Jember untuk maju ke PIMNAS 31 yang diselenggarakan di Universitas Negeri Yogyakarta. Bidang PKM yang kami ambil adalah penelitian eksakta dengan judul pemanfaatan radiasi medan magnet extremely low frequency atau ELF untuk meningkatkan kualitas produksi tempe. Inovasi kami adalah untuk meningkatkan kualitas produksi tempe, di mana untuk meningkatkan populasi Rhizopus oligosporus dan juga untuk meningkatkan usia simpan tempe tersebut. Teruslah berkarya, mahasiswa Indonesia.
Mahasiswa Universitas Jember tidak perlu khawatir untuk melakukan
Soalnya Pak itu ngomong ke sini. Aduh.
Assalamualaikum warahmatullahi wabarakatuh. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. A warm welcome to you all to the second international conference on physics and mathematics for biological science, or Airku. My name is Hiduplah.
My name is Dr. Tomo. We will be in charge for Master of Ceremony in this event.
Before we enter the official welcoming part, we will play the national anthem Indonesia Raya and then continue by the hymn of University of Jember. And now, let's enjoy the dancing performance from our students with the traditional dance of darahku.
thank you very much for all of the dancers, and it is our pleasure to welcome all of the participants here with us in this online international seminar. And we would like to thank you for all of you, even though all of us is facing pandemic or COVID-19.
A quick word about today's program. We will begin with a report from our chairwoman of the committee, and then a welcoming word from the dean of FKIP, and then second welcoming word will be coming from the chairman of the Dean's Communication Board, and an opening remark from the vice rector of Jember University. And the agenda then followed by a presentation from our honorable speakers. And lastly, we will have a session to share the ideas and results of the research.
And without further ado, we would like to invite our committee's chairwoman to Dr. Biwanyuni MSE. Time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Especially good morning, Forum FKIP. Welcome for joint meeting together in this international conference, second ECOPAM 2020. Distinguished guests and dear colleagues, Honorable Professor Subandi, ME, PhD, Chairman Forum FKIP. First of all, on behalf of the organizing committee, I am delighted to welcome you to the Faculty of Teacher Training and Education, Jember University. Also, I would like to thank you very much for embracing the right to attend second ECOPAM 2020. Let me say how pleased I am to see such a great number of participants here. About 112 participants have registered. This tremendous level of interest truly reflects the worldwide tension of natural science, mathematics, and education. I am also pleased to note that the majority of our participants come from various universities, both within and beyond Indonesia. I would like to address my special honor to our keynote speaker, Professor Adil Bagiro, PhD, Federation University, Australia. Dr. Ramos Nasimoto, School of Bioscience and Technology, University, India. Jana Serrano, PhD, the Director of Information Office, Faculty of Management and Development, University of Philippines. Welcome to the Faculty of Teacher Training and Education of Jember University. Our faculty includes 19 departments with 11 departments with A accreditation. And our lecture have successfully published more than 200 scopus in it. What is more, the most scopus indicate publication in our university always with our faculty. Some of our lecturers are currently in charge of reviewing articles and scopus in a journal. My dear, Professor David PhD have a Sinta Award 20 and 20. With almost 100 scopus in the scopus. As we all know, Ecobank 20 and 20 have agreement with IOP Publishing, contract signed in by Scopus. My conference is available online in forthcoming volume Journal of Physics Conference Series. I hope the conference become a annual agenda, making possible continuous development of knowledge. What is more, I would like to express my sincere appreciation to Chairman Forum FKIP, Professor Subandi, ME, PhD, Dean of the Faculty of Teacher Training and Education, University of Jember, Professor David, PhD, the organizing committee. I have shown the profound support in making this conference possible. I believe that you will have an exciting meeting here in Jember University. Please use this opportunity to interact with each other to the full in this unique opportunity and action you experience and ideas for the future. Finally, I wish all the success to the conference participants, and let me once again extend my warmest welcome and regard to all participants. I wish you an inspiring and enjoyable conference. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much for Dr. B. Next, we would like to have word from our Dean of Teacher Training of Education, University of Jember, to Professor David, PhD. Time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi dan salam sejahtera untuk kita semua. Om Swastiastu, Namo Buddhaya, salam kebajikan. Good morning for everybody. Alhamdulillahirabbil alamin. Assalatu wassalamu ala asrafil anbiya wal mursalin Sayyidina Muhammadin wa ala alihi wa sahbihi ajma'in, amma ba'du. The Honorable Rector of the University of Jember, Vice Rector for Staff and Finance Affairs as representative today, the Honorable all Deputy of Deans of the Faculty of Teacher Training and Education, the University of Jember, who joining in the session in the same room today, technician, will you please shoot my Vice Dean, bisa? Ya, ini coba. Nah, itu nggak bisa. Ya, ya, my Vice Dean, we have a bit longer time today until 8:30. Yeah, Vice Dean for Staff and Finance and also Vice Dean for Student Affairs. Sudah? the Honorable, all the invited speaker. Today we have Professor Adil Bagirov, PhD, a professor of the Federation University, Ballarat, Australia. I was graduated from there for the PhD level. So thank you very much for Adil Bagirov, who is willing to share your care research in our conference. And the Honorable Associate Professor Joanna V. Serrano, PhD, as well as Associate Professor Dr. Ramas Najimutu, each of them from Philippines and from India. Of course, for the lovely participants today who are already joining our conference in webinar format using the Zoom cloud meeting, I gratefully welcome all of you to our conference. It is the second international conference on physics and mathematics and science education. So thank you very much as well for the chairwoman, the organizing committee, Associate Professor Dr. Dwi Wahyuni, who organized this conference success from the 2019, the first conference, and now the second one is 2020. And for the special acknowledgement, I would like to thank to Professor Sufendi as the chairman of the Forkom FKIP Negeri se-Indonesia, who also joining with us today in this session, and he will give also remarks before the presentation of Adil Bagirov at 8:30 started. And all the organizing committee who successfully organized this conference. Today, it is part of the summit meeting of the Forkom 2020, which is held in the FKIP, the University of Jember. Ladies and gentlemen, today's session, the International Conference on Mathematics, Physics, and Science Education is a bit special as we organize this conference. At the same time, we have the sadness of the COVID-19 outbreak, which affects to all over the world, including Indonesian country. COVID-19 has taken so much thing from us, including economy, education sector, as well as human life. There are a lot of human being death toll, and there are a lot of people infected by these viruses, and hopefully this virus is over soon, and we will be able to do something in the new normal life. And we have a student in the classroom, we have a research in the laboratory again, and we are doing a joint research in the face-to-face format again. And we pray together, hopefully this pandemic over. But as a researcher, as an academician, I believe this pandemic cannot stop us to do a creative and innovation in research. We should do research as much as possible to have innovation, to have also a creation of the new result in the research. Of course, by using ICT, especially in the pandemic, we have learned so many things. COVID-19 not only give us a bad thing, but also give us a good thing. There are so many lessons learned that we already developed, especially when we implement the teaching and the learning in the classroom using Internet of Things. Now also we can do more research by using direct Zoom cloud meeting, for example, direct meeting using big blue button, for example, using Google theme or Microsoft theme or Google Meet, for example. So the COVID-19 is not a reason that we will stop our activity for the future life, future and better generation. But even this pandemic should motivate us to develop our research in such a way our university can improve the excellency, in such a way our university can achieve the university scholar performance as high as possible. This conference is a part of taking effort to invite the invited speaker from all over the world to share their idea in their current research. And our student, as mentioned by the chairwoman, we have at most 200 participants, can learn and can adopt what they have done, what they have got from their current research, and we can do a research as good as possible as they have done in other countries. And hopefully our target is successful as the previous year that we have provided the international conference. Then we can submit all the selected papers from the participants arising from the conference to the international proceeding, namely Journal of Physics Conference Series. As last year we have submitted at least 100 papers, and the GOP Conference Series has published and available online in GOP website. It is indexed by Scopus. The Scopus indexation is not the only one target to have this publication. We also have a regular submission for all other scientists who are willing to submit regularly in a journal, from the best quartile, Q1, Q2, Q3, and Q4. And you can request to the publication editorial board, when you consider your paper as good as possible, and then you can choose, I will have a regular submission. It is also possible. So the chairwoman will guide you until you have a publication. Ladies and gentlemen, the publication is the one of the research literacy indicator. When you are doing a research, not only you are smart in writing proposal, you are smart in writing proposal, also you are smart in carrying your research until writing a document of the research. But one thing to make is important is how to disseminate this research. The dissemination process of this research, of course, one of things, through the attendant operation of the seminar, international conference, when you talk to other people, and people will understand what is your current research that you have done so far. Or you can publish in the journal on the brochure. And finally, maybe you can develop a monograph. You can develop a book chapter. You can develop a textbook if you have already all the research. And then you can integrate in one book. And people will understand, people will read, and finally, people will give a feedback or impact to you through the citing your document. The number of citation will be considered if the number of page index or I-10 index. It is the real performance of the research. Secondly, doing research not only in innovation, also research, we do diffusion of the research. What is the diffusion of the research? The implementation of the research in the real life, the implementation of the research in social life. Now, today is the time for all of you to share your idea. After plenary speaker, we will have a parallel session. Please perform as good as possible and present your research to all of us. Hopefully, this conference is benefiting to all of you, and you will take a lot of lessons learned as best practices from this meeting. And I would like to say the final remark, and hopefully you enjoy this conference. Thank you very much. Again, hopefully you enjoy with this conference. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much for Professor David for some words to give speech for this today International Conference on Physics and Mathematics for Biology Science. And next, we would like to invite Professor Fendi as Dean's Communication Forum of Teacher Training and Education Faculty of Indonesia. So, could you please give us welcoming speech to Professor Supandi? Time is yours.
Dapat? Ya. Assalamualaikum warahmatullahi wabarakatuh. Very good morning, everybody. The Honorable Rector of Jember University, now represented by Vice Director, the Honorable Dean of Faculty of Teacher Training and Education, Jember University, my colleague from David, the Honorable, all my colleagues deans of Faculty of Teacher Training and Education all over Indonesia to attend this conference this morning. The honorable keynote speakers, one from Adil Bagirov from Australia, second, Dr. Ramesh Nachimutu from India, the third, Associate Professor Joanna V. Serrano from Philippines, the fourth, Professor Ismail from Turkey, my colleague, my friend from Dafiq, from Faculty of Teacher Training and Education, Jember University, Indonesia, as well as Associate Professor Dr. Dwi Wahyuni, also from Jember University. The honorable all presenters in this conference this morning, and also the honorable all participants, ladies and gentlemen. Alhamdulillah, this conference begins this morning on time. I, on behalf of Chairman of Deans Association of Faculty of Teacher Training and Education in Indonesia, appreciates from Dafiq and his colleagues from Faculty of Teacher Training and Education, Jember University, who have worked hard to prepare everything in line with conducting this international conference. In this occasion, I also like to welcome to all participants, as well as the keynote speakers, invited speakers, to this second international conference on physics and mathematics for biological sciences. This conference is held virtually, even though at the beginning of this year, Prof. Dafiq and his colleagues prepared this conference offline, held in Jember City. But unfortunately, because of COVID-19 pandemic, so we cannot get together in Jember City. So we do it virtually this morning. This conference is held in collaboration between Deans Associations of Faculty of Teacher Training in Indonesia and Faculty of Teacher Training and Education, Jember University, in line with Deans Association Summit 2020 this year. This summit is held for 4 days, started 2 days ago, and will end tomorrow afternoon. For this occasion also, I'd like to appreciate and to say thank you very much for the conference participants who have attended this conference. I hope you can enjoy your conference and share ideas, concepts, best practices, and other things. You know, you can have implementable outputs once the conference is over. I also appreciate this conference. It is a successful conference attended by staff participants from India, Philippines, Turkey, Australia, maybe from other countries too, as well as attended by some lecturers, teachers all over Indonesia. For this occasion, I also appreciate the conference committee at Faculty of Teacher Training and Education, Jember University, who have prepared everything for running this international conference. I think that's what I can say for this moment. Have a nice and informative conference. Hopefully, the output of this conference, we can share these outputs with all our colleagues, lecturers, teachers, not only Indonesia, but also from other countries. Enjoy your conference. Hopefully this conference will bring us to higher level of understanding of the physics, mathematics, or biological sciences. I think that's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much for Professor Sukmenti from the University of Sriwijaya. And for the next one, unfortunately, we just have the information about if our vice rector should not hand to open this session. So we would like to invite our dean, Professor David. Professor David, could you please? Okay, thank you. Okay, for Prof. Fendi, since you will be the person who will open this session, could you please open this international conference on physics and mathematics for biology science for the second session? Professor Fendi, thanks yours.
Okay, thank you very much, the moderator. So on behalf of Jember University and on behalf of Dean's Associations of Faculty of Teacher Training and Education in Indonesia, I open this conference formally. Hopefully, this conference will be beneficial to all of us. Now, let's say together to open this conference officially. Together we say Basmalah. Bismillahirrahmanirrahim. Thank you very much.
Thank you very much for Professor Sukmenti for officially open this session. And next, we would like to invite Dr. Fadli to pray before we jump to the main session. So for Dr. Fadli, please ensure.
Assalamualaikum warahmatullahi wabarakatuh. A'udzu billahi minasy syaithanir rajim. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin. Hamdasy syakirin hamdan na'imin. Hamdan yuwafi ni'amahu yukafi mazidah. Ya Rabbana lakal hamdu kama yanbaghi lillahi 'azimi sultanik. Allahumma inna nas'aluka salamatan fid din wa afiyatan fil jasad wa ziyadatan fil 'ilm wa barakatan fil rizq wa tawbatan qabla al-maut wa rahmatan indal maut wa maghfiratan ba'da al-maut. Allahumma hawwin 'alaina fi sakaratil maut wan najata minan nar wa afwina hisab. Loving and gracious Allah subhanahu wa ta'ala, you are indeed the giver of all good gifts, and we thank you today for all your blessing. Come fill our lives with your love, fill our conversation with your grace and truth, fill this conference
the second International Conference on Physics and Mathematics on Biological Science with your presence. Allahumma ya Allah ya Rahman, sallimna wal muslimin. Allahumma inna nas'aluka ilman nafi'ah wa rizqan wasi'ah wa shifa' min kulli da'in wa saqamin bi rahmatika ya arhamar rahimin. We ask that you bless us abundantly, and we continue to seek your wisdom, guidance, courage, and strength. Be with us in our deliberation and help us to be wise in the decisions we make for the good of all those who have placed their trust and confidence in our conference. Ya Allah, Ya Aziz, Ya Raffal, Ya Rabbal Alamin, Allahumma yassir lana wa la tu'assir. Give us insight to live integrity, that our hard work may reflect what is right and good. Keep us from short-sightedness and pettiness. Help us to make contributions to science that are for the good of all, and guard us blind self-interest. Then Allah subhanahu wa ta'ala grant us the humility to always seek your will in all that we do and say. All glory to be you, loving Allah, now and always. Amin. Rabbana zalamna anfusana wa illam taghfir lana wa tarhamna lanakunanna minal khasirin. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzabannar. Wa adkhilna jannata ma'al abrar. Ya Aziz, Ya Ghaffar, Ya Rabbal Alamin. Subhana rabbika rabbil izzati amma yasifun. Wa salamun alal mursalin. Walhamdulillahi rabbil alamin. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much for the topic.
Ladies and gentlemen, moving right now, we come to our main session, which is the presentation from our keynote speakers. It is now my pleasure to introduce you to our first keynote speaker, Professor Bangunlah, PhD, from Federation University of Bangunlah. With the moderator leading the session is Mr. Muhammad Iqbal. To Mr. Muhammad Iqbal,
satu orang ini.
Thank you. Ladies and gentlemen, before we start the presentation, in order to avoid any disturbance during the presentation later, I would like to ask you to mute your Zoom to avoid disruption during the presentation. Thank you. Honorable Mr. Speakers, distinguished guests, fellow students, and ladies and gentlemen, good morning. Assalamualaikum warahmatullahi wabarakatuh. First of all, I would like to welcome you all to this prestigious conference, the second International Conference on Physics and Mathematics for Biological Science, ECOPAMS, held by Faculty of Teacher Training and Education, University of Jember. In this occasion, we shall have outstanding presentation from our prominent keynote speakers, whom I believe shall enrich our insight and knowledge regarding the theme of this conference. Before the presentation begins, allow me to introduce the first keynote speaker. Our first presenter is Professor Adil Bagirov, PhD. He received a master's degree in applied mathematics from Bangsa State University, Azerbaijan, and the candidate of science degree in mathematical cybernetics from the Institute of Cybernetics of Azerbaijan National Academy of Science, and PhD degree in optimization from Federation Australia University Australia, formerly the University of Ballarat, Australia in 2002. Work at the Space Research Institute, Baku, Azerbaijan, Baku State University, Azerbaijan, Joint Institute for Nuclear Research in Moscow, Russia. Professor Bagirov is with Federation University Australia, or Ballarat University, since 1999. Currently holds the full professor position in this university. He has won 5 Australian Research Council discovery and linked grant to conduct research in non-smooth and global optimization and their application. He was awarded Australian Research Council Postdoctoral Fellow and Australian Research Council Research Fellow. He is Europe Fellow in 2009. His main research interests are in the area of non-smooth and global optimization and their application in data mining, regression analysis, and water management. Professor Bagirov has published 2 books on non-smooth optimization and its application, one book and more than 160 journal papers, book chapters, and papers in conference proceedings. Okay, ladies and gentlemen, without further ado, I would like to welcome our first presenter. Ladies and gentlemen, please welcome Professor Adil Bagirov, PhD. Prof. Adil, the stage is yours.
Okay, Professor Iqbal, can you hear me? Okay, I will maybe also open.
Okay.
Can you see me? So, Professor Iqbal, can I start?
Yes.
Yeah. Okay. Thank you very much, Professor Iqbal, for your introduction. And first of all, I would like to thank Professor Tafik for inviting me to give this talk in this nice conference. Unfortunately, it's a little bit pity that we cannot come personally to visit your this very nice university. I have seen now on these videos that it is a beautiful place, and I hope that you have very good students and your university will improve its research in future as it's going up according to Scopus and other database, scientific database. So today I will talk about optimization models and the methods in machine learning. So that is outline of my talk. This is first I will give a brief introduction, then I will consider 4 different types of problems from machine learning where we can apply optimization approach, optimization models and algorithms to solve those problems. And then I will maybe give some very brief sorry, that one. One second, I have fixed this problem. Okay, I think that is better because, okay, so machine learning is a scientific discipline that's concerned with the design and the development of algorithms that allow computers to learn based on data, such as from databases. So data analysis is about gathering, modeling, and transforming data with the goal of highlighting useful information, suggesting conclusions, and supporting decision making. So machine learning is now becoming a huge area. This is more mathematical area, not say artificial intelligence. And machine learning is different from artificial intelligence. Artificial intelligence is more equipment and other stuff, but machine learning is more development of algorithms, which is more mathematical discipline. So you know, in data analysis, we use different keywords, and it is important to understand what are differences between them. So data analysis, as I mentioned, this one, machine learning is about algorithms to solve those problems from data analysis. And another word which we use is data mining. So data mining is the process of extracting hidden patterns from data. So say 100 years ago, maybe 50 years ago, mainly mathematics was applied in physics and also in economics, not in many other areas like biology and some business in these areas. But now machine learning has many applications in those areas, especially in biology, because in biology we have a huge, we can collect huge amount of data, and we need powerful methods to solve problems from there. So that means that nowadays we face huge problems in to solve challenging problems in machine learning, and especially when we talk about big data. Okay, I will not go into detail of that big data, but my aim here to demonstrate that optimization provides powerful methods to solve very challenging problems in machine learning. So, okay, optimization and the mathematical programming actually are almost the same words. They are synonyms in some sense for us. But I will in particular consider non-smooth optimization because this is an area which I am working for a long time, and I designed algorithms for machine learning, using non-smooth optimization approaches and algorithms. So, and we will consider 4 different problems from machine learning. It's called data classification or supervised data classification, clustering and cluster-wise linear regression, and regression analysis. So regression analysis was part of statistics before, but now most people consider this one as a part of machine learning. So let us start with clustering. So in cluster analysis, we assume that we have been given a finite set of points A in the n-dimensional space Rn. That is, we have m points in n-dimensional space, and our aim is So to distribute this set of points into a given number k of disjoint subset Aj with respect to predefined criteria such that all these subsets are non-empty, they are pairwise disjoint, and their union gives us the whole set A. So that is, how to say, the definition of a hard clustering problem. Of course, there are some other problems also in clustering, but we will consider only this hard unconstrained partition clustering problem. So when we talk about grouping of points, we have to define how we do it. I mean, it's based on similarity. So similar points are in the same group, dissimilar points are in different groups. And how to define this similarity measure, we can use this different norms, distance functions. So we have here, I listed here only 3 of them, but in fact we can add more here. So first one is called Manhattan or city block norm, using that one, or we can, if we want to call it mathematically, this is L1 norm. Second one is squared L2 norm, and the last one is a Chebyshev norm, or we can also call it this L infinity norm, if we follow that one. So then we can formulate using that. Once we defined the similarity measure, we can model our problem. There are different models of this problem using optimization techniques. One is called mixed integer programming model, where we have this, I hope that you can see this mouse on my screen. So we have this function psi, and we have, this is our objective function. You can see that it involves this coefficients, and we have similarity measures. So xj are for cluster centers, and ai is data point. So then we have our decision variables are this all this collection of cluster centers, and also membership of those points ai. So we have this one here. So each point can be in only one cluster. So meaning of this one is here. And it is 0 if point AI doesn't belong to cluster J, and it is 1 otherwise. So this is you can see here, we have a huge number of this so-called binary variables, because it is binary, because it has only 2 values. And the number of those binary variables is m times k, which can be quite large, especially m usually is large in nowadays clustering problems. We make hundreds of thousands or even millions of points, and this in this model number of binary variables can be quite large here. So that's why we developed new model called non-smooth optimization model by introducing here so-called minimum function, and we removed from here all these decision variables about membership of data points. So here we have to minimize this function, which has only k times n. N is a number of coordinates, or we can call it also features, attributes, etc. There are different names for them. And altogether they have nk, which is significantly less than in previous one. But only we have a problem, which is here is this function is a non-smooth function because of this minimum operation. And if you use L1 norm, also L infinity norm, then always, even without that minimum, you have so-called non-smooth function. Non-smooth function is function which is not differentiable everywhere. Of course, I mean, in real applications, our functions are not so complex in the sense that they are locally Lipschitz continuous functions, and those functions are I mean, their set of, I mean, Lebesgue measure of set of points where function is not differentiable is 0. Of course, I mean, this is a good sign, but still, even if they have 0 measure, they can create too much problem when you design algorithms for solving, for minimizing such functions. Okay, we can also consider so-called non-smooth DC optimization model by representing previous function as a difference of two convex functions. You can see here that this one, but again, this function, if we consider here squared Euclidean norm, will become a smooth function, meaning is that it is continuously differentiable, but second function is very complex function. It is because of this maximum operation inside this one, we have non-smooth function. So DC representation may help us to design better algorithms, but we cannot avoid, of course, problem with non-smoothness of this function. Okay, I already talked about this one. Now, so this was two main models in clustering where we use optimization models. Both are, again, I have to say that they are non-smooth optimization models. So we have two different models here. So, I mean, algorithms we can develop based on those models. They are completely different because they based on completely different models. So most important thing here is that we have not many variables. Usually we don't calculate many clusters. We can calculate 10, 20, and usually we don't have many. Nowadays we have only many records in our data set. This means that we have many data points. They can be millions, which is here. So that this number is huge number in comparison with this number. So meaning is that yes, we make our function a little bit complex in the sense that we make it non-smooth, but we get advantage in the sense of size of our problem, which is also very important, especially when you are talking about big data. Sorry. Now I want to move to next this problems class of problems in machine learning. It's called data classification, but also there is another name for this one is supervised data classification. So this class of problems is different from previous one. Here we have so-called class labels, meaning is that you can, if you have two classes, you can divide any given data set into two parts. Or if you have many classes, you will divide it into many. So you have some prior information about your data. In the case of clustering, we don't have such information. So here we assume that let us make things a little bit easy for us. Consider only two classes. So meaning is that we have two sets, A and B, and each class has finite number of points. And our aim to find function which will separate these two sets. Okay, we know from convex analysis that if we have two disjoint convex set, we can separate them using one linear function, or we can call it hyperplane. Okay, but reality is different. That one linear function is not enough to separate two sets in real life applications. So here we give this definition of linear separability for given set A and B. So meaning is that these two sets are linearly separable if there exists a hyperplane X, which is normal vector for that hyperplane, and Y is its intercept. With X is, of course, this is vector and this is scalar, such that for any point from A, value of this linear function is negative, and for any point from B, value of this function is positive. So meaning is that here, I mean, this is notation is for inner product in n-dimensional space. So meaning is that you can draw one line between A and the B, and A will be in one side of that line and the B will be on another side of that line. Okay, this is the example of that one. Okay, so we have these two sets here, A and the B, and we can draw a line which will separate these two sets. And from convex analysis, we know well that in this case, a convex hull of A and the convex hull of B has empty this intersection. So how to find this hyperplane? We can formulate this problem where our function is given like this. This is, we call it error function. So error function simply means that if we have hyperplane and the point which is from A is in wrong side, this is misclassified, then we have positive number here. If a point from B is on wrong side of that line or hyperplane, then we have a positive number here. So our aim is to make sure that we minimize that error function, to make sure that we get best hyperplane separating two sets. Okay, that in fact the problem is not so difficult problem. Of course, I put here maximum here and here. It makes function a non-smooth function, but we can reformulate it as a here as a linear programming problem. And you know that it is easy to solve such problems, even if you have hundreds of thousands of variables, because we have now powerful software to solve such problems. But as I said, in real life applications, in most cases, we don't have linear separability. Then next to linear separability is called polyhedral separability. I think that I have a picture of that one. So we have two sets, B and A. That polyhedral separability means that you have finite number of hyperplanes or linear functions which will separate this set A from the set B. So you can draw this part, and this part we call it polyhedral set. Okay, how to get this one? Definition is mathematical definition is given here. Now instead of one hyperplane, we have H hyperplanes. Okay, and for each of them, for set A, we have to have all of them negative. And for another set B, at least one of them should be positive. So that one is given here. So you can see here, if I draw this line and continue here, this part in on one side, but this part is in wrong side, sorry, where we have set A. Meaning is that for this linear function, these points, we have a positive one, but here we have negative values. That's why we need one more. When we draw this one, now for this two, we have all these are positive, but this part still is negative here. That's why we need one more here. Then we will have at least for one of them, all these points, we will have positive value. But for all of them, we will have negative value on this set. So that is, meaning is that we approximate this set using some polyhedral set. So polyhedral set, you know definition, that is set which can be represented as an intersection of finite number of half spaces. Okay, so I have one half space here, another one here, and third one is here. So I get the intersection, I will have this set. So that is a polyhedral set which approximates set A, and it separates set A from set B. And now we can give its how to calculate those hyperplanes. We have this mathematical definition, optimization model for that one. So we have now new error function, which is different from previous one. And here, this function now is more complex one. Okay, this function is piecewise linear, but it is in general non-convex piecewise linear function. So that's non-convexity is here because of this minimum operation. So how to solve this one? Now we have global optimization problem, and it's not always easy to find its global minimum. If two sets are polyhedrally separable, then value we know exactly. This is 0. But how to find it? This is another question. So again, in real life situations, we may have cases when we don't have even this type of this separation. We cannot say approximate any of this set by polyhedral set. What we do in that case, we use simply piecewise linear functions. I think that this is maybe not say like this. Okay, but maybe better to put this one also. So you can see that we now have two sets. They contain finite number of points, many points, and there is no any way to separate them using one line or to approximate any of them using only polyhedral sets. So we have to have this type of piecewise linear function, more general piecewise linear functions. And this type of separation, we call it max-min separable. So because we will use this type of functions here to separate these two sets. And that's why we call this separation max-min, okay, better to call max-min linear separation because we have linear function here. So this problem becomes, I mean, we can formulate how to, I mean, in order to find this decision variables, x and y. What we can do, we have this, okay, I think that this was better picture. So you can see here, we have set A on this side and set B on this side. So it is not easy to find any linear function. If you draw this one, it will go through and will cut part of this set and also part of this one. There is no linear separability here, and there is no any polyhedral separability. So if you go this way and then come here, you will put some points from B on side of set A. So there is no polyhedral separability also here. So we have a more complex, but we have this type of piecewise linear functions separating these two sets. And this one will bring us a very complex problem because now you can see that we have both functions. I mean, this is a function again, we call it area function, average area function. And this function, both functions are non-convex, but they are piecewise linear function, non-convex piecewise linear function. It's not easy to solve this type of problem because this problem, as I said, this is non-convex optimization problem, and it is global optimization problem. But we can, I mean, we can this formulate as an optimization problem. But we know, I mean, we developed algorithms for minimizing, not getting a global minimum, but some kind of a good solution to that one. I think that I can skip some of them here. Now I can move to again, I mean, in the area of this data mining. This is supervised data classification, but it's well-known algorithm called support vector machines. Support vector machine is very powerful when we don't have large sets. It is very good and easy to find, I mean, to solve those problems because they are convex quadratic programming problems. So what is the main idea here? You have two sets. And the idea is to find this, I mean, this is two hyperplanes, linear functions. These two hyperplanes are parallel to each other, and the aim is to maximize so-called margin. Margin is this is distance between these two lines. Of course, if we don't have this linear separability, then you have some problem. How to solve this problem, of course, you can find in some papers about support vector machines. But what is important here, when you have this so-called we may have in supervised data classification, we have this labeled data and unlabeled data. So transductive support vector machines is about using both. Labeled, usual support vector machines, they use only labeled data. But here we can, in transductive support vector machines, we can use also test data. So again, if we go back to this picture, aim here to make sure that we don't have any point, it doesn't matter from training set or from test set, we don't want to have any point in between these two lines. So that's the idea here, but that brings us so-called non-smooth optimization problem. And the problem is given here. So first part is coming from support vector machines. This is a quadratic function, and we put this one here. So good function here, smooth, continuously differentiable function. But here we have, because of test set, which we add here, unlabeled data we add here, we will have non-smoothness because of this absolute value of t. So all this number you have to put here, 1 minus this one. So you will have a non-smooth function to minimize, and that function is also non-convex. So that's not, say, again, non-convexity creates problem because we have many local solutions and we are looking for only solutions which are global or maybe quite close to global one, because they provide good separation of two sets. Now, okay, this was all about non-smooth optimization models in supervised data classification. I want to say a few words about regression. First, this concept here is so-called cluster-wise linear regression. So I think that I have some pictures here I can show you. So in multiple linear regression, we use only one linear function to approximate our data. So to draw something from here. But here in cluster-wise regression, aim is to use more than one linear function to approximate the data. Such, I mean, these problems we can see in many places, and also in finance especially. You know what is happening with shares. They can increase, and one they drop, and they then again start to increase. So you have a completely different linear functions to approximate such time series. So that has, I mean, started from there, but now there are other applications of cluster-wise linear regression in other areas also. And one area was we applied was rainfall in Australia to predict rainfall. This is very important for Australia, maybe not very important for Indonesia, because you have some enough water there. So here, as I said, easy to model this problem when you have one linear function. This is a so-called multiple linear regression model. But if you have more than one linear function, say here we have 4, here we have 2, then it becomes quite difficult to find those linear functions, because you have more than one linear function. So here we combine two different techniques. One, which already I mentioned, is a clustering problem. So meaning is that we divide the whole data into subsets and approximate each of them using one linear function. So a definition of a cluster-wise linear regression is similar to that of for clustering problems. And so you can see the same here. But here we have in clustering, if you remember, we had one, for each cluster we had its center. But here, instead of 1 point, we have line approximating each cluster. So this all definitions are coming from clustering, but we have to approximate each of them. So how to approximate? We use one line for each cluster, and this is coming from multiple linear regression. But since we have many of them, we take that line for each data point, whose regression error at this point is smallest. Smallest word is about minimum. That's why we need here this minimum operation. But this minimum operation makes my function non-convex and non-smooth function. Okay, so meaning is that problem itself from the beginning is global optimization problem, and using this non-smooth optimization approach, we can significantly reduce decision variables here. Okay, it's given here. So in the case of this P if equals 2, you know, this is least squares regression, so well-known technique. But here again, we have many of them, not one problem. That's why we have several. That's why we use minimum operation here, and our function becomes non-smooth function. And also we can consider its DC optimization model represent that function, objective function, as a difference of two convex functions. Convex functions are good functions for point of view global optimization, because their local solutions are always global solutions. So that's how to say, that's why very attractive for us. And here, first function, if we use least squares, then this is a continuously differentiable function. But this second function is very difficult, complex, non-smooth function. So again, using original model, which was in previous slides here. So this one, or we can use this DC optimization model. We can develop different methods, and depending on data sets, one can be more efficient than another one, more accurate than another one. So that is how to say what may happen in real applications. Finally, I want to move to this piecewise linear regression method. So using one linear function usually may not lead to good prediction results. We face this problem when we solve this real life problems, especially I also use them in prediction rainfalls and other stuff also. So experience shows that one linear function is not enough. So that's why we move to use this non-linear function. So one idea was to use, again, support vector regression, because support vector methods, machines, they are good that we can use kernel, and using kernel, we can make this instead of using only linear function, we can use non-linear functions. But problem in this support vector regression is that we don't know, which kernel to use here. But those non-linear functions can be approximated by piecewise linear functions. So that actually will bring us to another model of regression problems, and that model is non-smooth optimization model. Here we give a definition of this regression analysis. I hope that most of you are familiar with that one. So aim is to minimize this function to find estimation. So in order to find, we don't know exactly which function we have to use to approximate our so-called regression function, because we don't know regression function. We know only some numbers. Input and output is several measurements about our function. So we have to get, to take any set of functions and minimize this difference, this so-called regression error in over this set. And one idea here is to use so-called piecewise linear functions. And those piecewise linear functions, continuous ones, can be represented as a maximum of minimum of linear function. This is quite a complex one here, but when you apply, it's not so complex, in fact. So that will bring us this type of this regression error function, which we have to minimize. Again, this becomes a non-smooth and also non-convex optimization problem. And we developed several algorithms how to find it's at least a good quality solution. I don't say that we can find a global solution to this one always. Another model here is so-called DC optimization model. So that function, which is here, yes, very complex function, but we can represent it as a difference of two convex functions. Again, one convex function is a little bit easier than another one, and we can develop good methods to globally optimize this function F, capital F here. So but again, we cannot avoid problem with this. We cannot avoid problem with this non-smoothness, because non-smoothness in the nature of this problem. And finally, we can improve this support vector regression by embedding this piecewise linear function inside this linear SVM regression problem. So because usually when we formulate linear regression problem or linear data classification problem, then we can use the kernels to consider non-linear functions. But again, how to choose kernels is also a challenging problem. So those linear functions can be approximated by piecewise linear functions, and it will bring us this type of problem. I mean, to generalize this support vector regression problem to this problem here, which we have here. This one problem. This is non-convex, non-smooth optimization problem. First one is a quite nice quadratic function. Second one is piecewise but non-convex function. So also this model is non-smooth optimization model, and it helps us to get to avoid problem of choosing kernels in this problem. So we can consider it's a DC optimization model as well, DC representation of that one, and to develop algorithms, design algorithms based on DC model of support vector regression problem. So we consider it in 4 different concepts in machine learning, and in each case I try to use optimization approach first to model that problem and significantly reduce decision variables to extend them to solve those problems: clustering, supervised data classification, cluster-wise linear regression, and regression problems in large data set, which is important nowadays. Okay, I would like to stop here. I have some examples, but I think that that's not so important. Thank you very much for your attention, and I'm happy to answer any question.
Okay, thank you very much. Let's give now we come to question and answer session. Ladies and gentlemen, there will be 2 sessions, and each session is for 3 questions. Please press raise hand icon to ask question, and also mention your name and institution before the question. Or you can also deliver the question by Zoom chat features. Okay, please for the question. If there are any questions from participants. Is a very advanced explanation from Professor Bergilov. So can we have your presentation, Prof? Because some of participants asking us to have your presentation so they can read again in the time.
Yes, I don't see any problem. I think that I sent to you that presentation, and you can, I would say, give or put on website somewhere that everyone can have access to that. Absolutely no problems.
Okay, thank you very much. We will deliver your presentation to all participants so they can read your presentation later. Okay, ladies and gentlemen, is there any question? Please raise hand, or you can deliver your question from chat feature in this Zoom. Is there any question? In this room? Participant in this room, any question? Okay, Prof. Begirov, apparently there is no question.
Yes,
But,
thank you.
I think we will have still taking question, and we will deliver it for you, maybe with email or the other.
Yeah, no problem.
Okay, yeah.
Okay, thank you very much.
Professor Begirov. Ladies and gentlemen, let's give once again a big round of applause for Mr. Professor Begirov.
Okay, thank you very much.
Thank you very much.
Thank you.
All right, ladies and gentlemen, and for the second presentation, we will have the educational topic here. Since the participant is a lot of educational lecturers and teachers also. Before the presentation begins, allow me to introduce the second keynote speaker. Our second presenter is Associate Professor Giovanni V. Serrano, PhD. Serrano is Associate Professor of the Faculty of Management and Development Studies, University of Philippines Open University. She is the current Director of the UPLU Information Office. She obtained her Bachelor of Science in Development Communication from University of the Philippines, Los Baños. She also earned her Master of Management Major in Development Management and Doctoral of Philosophy Major in Development Communication from same university. Over the last 2 decades, she has authored a number of international and national scientific publications, research in various international and local conferences, and served as a research speaker in various trainings, seminars, and fora in various areas such as open and distance e-learning, environmental advocacy, developmental communication, and educational technology and other relevant fields. All right, without further ado, I would like to welcome our second presenter. Ladies and gentlemen, please welcome Associate Professor Giovanni V. Serrano, PhD. Dr. Serrano, the stage is yours.
All right, thank you. Sorry, I was, good morning, everyone. Sorry, I was on mute. Okay, so greetings from the Philippines. How are you, everyone? I hope everyone is safe despite the current situation that we are in. So let me just share my screen. Okay, I hope everyone can now see my screen. Okay. For this morning, I will be talking about technology and education. So this is quite far from the topic earlier, but this is very relevant to educators like me, especially to teachers, because many of us will definitely be using, if not all, will now be using technology when it comes to education. So when we talk of technology, technology is defined as the sum of techniques, skills, methods, and processes used in the production of goods or services or in the accomplishment of objectives such as scientific investigation. Technology can be the knowledge of techniques, processes, and the like, or it can be embedded in machines to allow for operation without detailed knowledge of their workings. And when we talk of information and communication technology, or ICT, it refers to a diverse set of technological tools and resources used to transmit, store, create, share, or exchange information. These technological tools and resources include computer, the internet, such as websites, blogs, and emails, live broadcasting technologies such as radio, television, and webcasting, recorded broadcasting technologies such as podcast, audio, video player and storage devices, and telephony, which are fixed or mobile, satellite, and video conferencing. And we all know that technology has impacted almost every aspect of our lives today.
Education is no exception. Sorry, let me just fix my audio.
Okay, can you write it?
Dari sana berarti ya? Iya, kita aman.
Bukan dari sini.
Bukan itu. Di komunikasikan masuk. Sudah. Masih pakai suara aja, Pak. Pakai suara ya.
Okay, we will waiting for Dr. Serrano to fix the presentation.
Bangsa la Philippines. Conexinho. Iya.
Dr. Serrano, are you with us?
Can you hear me?
Okay, we hear you.
Sorry, let me just change my audio because I think I have some problem.
All right.
All right, how about this one? Can you hear me?
Yes, we can hear you clear.
Okay, sorry for that. Let me proceed with my presentation. Can you allow me to enable my screen sharing, please?
Sudah. Jadikan fokus saja, Pak. Sudah fokus. Oke, sudah.
All right, okay, you can share your screen.
Okay, thank you very much, and apologies for that. Okay, so let me proceed with my presentation. So as I was saying, technology has impacted almost every aspect of our lives today, and education is no exception. And this is especially true in this time of pandemic, wherein everyone is forced to make use of technology in order to ensure learning continuity. Okay. So the use of ICT in education is really not something new. If you will look at the screen on the left, this 14th century illustration by Laurentius de Voltolina, depicts a university lecture in medieval Italy. And the scene is easily recognizable because it actually parallels to the modern day. The teacher lectures from a podium at the front of the room, while the students sit in rows and listen. Some of the students have books open in front of them and appear to be following along. In this picture, we can say that technically, books are products of printed technology that facilitates learning. The picture on the right is not much different in terms of class layout. Hence, the classroom or lecture hall does not look much different from the picture on the left. But what is notable is the use of ICT both by the teachers and the students. The teacher uses the projector while the students have their own laptops, tablets, or smartphones instead of books. So before the pandemic, this is what our lecture hall looks like. We have been using technology in delivering education to our students, and this has been working for us fine for the past years or so. If we will look at the evolution of technology, it's amazing how quickly it changes. If you will look at the figures on both sides, in the past, technology changed in the course of decades. Um, so before one technology is developed, it would take years for another technology to take the place of of that particular technology. So if you will look at the figures on figure on the left and on the right, it took a number of years before one technology in terms of ICT is developed and is adopted by by the learning community. But as technology becomes more modern, technology changes more rapidly. And we have seen in recent decades the dramatic accelerating pace in the development and adoption of new technologies. This is despite the various gaps that persist in terms of adoption in different parts of the world, especially in the global south. This rapid technological change is affecting almost every area of the economy, society, and culture. As we now live in an information and knowledge-based society, the fundamental role of information and communication technology, or ICT, is widely recognized. And the COVID-19 pandemic has further hastened the acceleration of key technologies and developments. And we all know that before the pandemic, there was still an ongoing debate on the use of technology and education. Everyone had their views on the use and importance of technology when it comes to education. Although there were a huge number of positives or supporters of technology enhanced learning, there were still those who viewed the use of technology in education negatively. If there's an important lesson from COVID-19, it's the realization of the importance of digital readiness, which allows business and people's life to continue as usual during pandemics. This realization has become apparent not just to those who support the use of technology and education, but even to those who hold a negative view on the use of ICT in education. The pandemic has allowed the rapid adoption of technology, which has been impossible in the past decades. In the past, I know that as teachers, you have experienced co-teachers and students resisting the integration of technology in teaching and learning. And many have refused to learn digital skills and use digital technologies. And they have been saying that there is really a need for it because they're able to survive and they're able to provide quality education anyway without the use of technology. But with the pandemic, everyone is forced to use technology as a matter of survival. And the COVID-19 pandemic has unexpectedly become a catalyst for technology adoption. And experts are saying that COVID-19 pandemic is the ultimate catalyst for digital transformation and will greatly accelerate several major trends that were already well underway before the pandemic. So the picture in this screen is a training which I recently conducted among faculty members teaching agriculture, fisheries, and forestry in one of the remote regions in the Philippines. In the past, this use of technology would not have been possible due to various factors, including one of these factors include, of course, access to technology, and another is the resistance of teachers to learn digital skills. But because of the pandemic, teachers are forced to adapt and adjust to technology in order to ensure the continuity of education. Although we are in the midst of a pandemic, we must not lose focus on what we as a society must be doing. And as we start to feel the effects of COVID-19, UNDP estimates global human development, a combination of education, health, and living standards. This means that in this year, their prediction is that the global human development could fall for the first time since 1992 when they start measuring now the effects of COVID. And UNESCO estimates about 1.25 billion students who have been affected due to COVID-19 closures, and 86% of primary school children in developing countries are not being educated. And this high rate has not been seen globally since the 1980s. And the school closures carry high social and economic costs for people across global communities. Their impact, however, is particularly severe for the most vulnerable and marginalized boys and girls and their families. And the resulting disruptions exacerbate already existing disparities within education system, but also in other aspects of their lives. Now, UNESCO has summarized the catastrophic impact of the current pandemic to global society. So we are experiencing now interrupted learning. This is not just happening here in the global south, but also happened or still happening in the global north. There are much confusion and stress among teachers. So we are now forced to do this kind of meetings and interaction over the internet. And it has actually really caused a lot of stress because many teachers are still getting used to this kind of setup, and we are not used to doing it yet. And then parents are unprepared for distance and homeschooling. So this is one of the impact of this current pandemic because teachers have always been teaching in classrooms, but now many schools will be delivering their courses via distance or remote learning. And there's also challenges when it comes to creating, maintaining, and improving distance or remote teaching and learning. And there's increased pressure on schools and school systems to remain open. And of course, we can see rise in dropout rates, and of course social isolation, which can lead to, of course, various problems, especially in terms of mental and wellness, well-being of our teachers and students. And there are various challenges in measuring and validating learning. Now with this enormous impact to society, one area that needs refocus is ICT and education, which is part of SDG 4. SDG 4 is ensuring inclusive and equitable quality education and promote lifelong opportunities for all. Even before COVID-19, progress towards inclusive and equitable quality education was too slow. Now, with the school closures, 90% of all students will be out of school, reversing years of progress in education. The inequalities in education have also been exacerbated by COVID-19. Remote learning remained out of reach for at least 500 million of students globally. Among the targets of SDG 4, so here are some of the targets related to ICT. First is the increase in the number of youth and adults who have relevant skills, which include basic and ICT skills. Next is target 4.5 to eliminate gender disparities in education through ICT training, access to appropriate technology and infrastructure. Target 4.6, which is ensuring that all youth and adult achieve literacy and numeracy, which includes promoting the use of ICT, particularly mobile technology. And target 4.8, which is building and upgrading education facilities to improve access to ICT resources, increase number of schools with access to the internet and computers for pedagogical use. And target 4.C is to increase the supply of qualified teachers or teachers with adequate technological skills to manage ICT. So despite this current situation that we are in, we need to refocus on how to achieve these targets under ICT in SDG 4. And as you can see, technology plays a very important role in achieving ICT in SDG 4. Now, in this time of crisis, technologies indeed play a crucial role in keeping our society functional, especially in areas that are still in lockdowns and quarantines. So here in the Philippines, we are again back to lockdown mode. So we are still working from home, and classes will be starting, I think, 2 weeks from now. And most of the students here will be really doing remote teaching and learning. And technology, we have to remember that technology will be crucial to restarting society as we slowly return into normal, but not really the old normal, but the new normal. The question now becomes, how can we continue the momentum and use the lessons learned in the crisis to leverage technology for good, especially the accelerating progress on the United Nations Sustainable Development Goals? Now, we all know that despite our best efforts, the digital divide, which is the gap between those who can and cannot easily and affordably access the internet and technology, still persists. And there is a need for everyone to work together to redouble our efforts to make sure that everyone can benefit from these life-changing technologies. So this might be an old data, but I think not much has improved. I'm not sure with Indonesia, but in the Philippines, there are still very few schools with internet access, which is why when the basic education resumes their classes in August, a lot of parents are opting to do the modular learning, because many parents, many homes do not have access to the internet. And even schools do not have internet access, which means that teachers will not also be able to provide learning to their students through the use of technology. Among the other challenges when it comes to use of technology in education are cost implication. It's not easy to keep up with rapidly changing technology. Hardware and software represents major investments for governments, school, parents, and students. And technology adds complexity to everything. the support, the teaching, the learning, the budget, etc. And it is inherently disruptive and requires careful consideration when used in education. And one of the major challenges is to provide appropriate and adequate training for teachers. This is especially challenging for public schools, considering the number and the different location of the teachers. So I know that this is also true for Indonesia. In the Philippines, which is an archipelagic country, teachers are located all over the islands, and it's very difficult to train all of them on the use of technology. And let me just highlight this challenge. One of the fundamental challenge in the use of technology is that oftentimes there is the lack of alignment between technology, pedagogy, and content, which pose problems in the success of the learning of students. Now, this is very important, especially for you as teachers, that we should be able to see the dynamic interaction among technology, pedagogy, and content. Now, to address this challenge, to address the last challenge that I posed, it's important for teachers using technology and education to be proficient not just in the subject matter or content we teach. For example, you're teaching biology, chemistry, mathematics, or physics. It's not important. It's not enough that you are just knowledgeable on the content, but it's important that you should also be knowledgeable on the pedagogical and technological aspect of it. And let me share with you this framework. According to Mishra and Kohler, there is a problem when we separate the discussion of pedagogy and technology. So they mentioned 4 major problems. The rapid changes in technology make it extremely difficult to keep up with all the latest advancements in apps. Every day, hundreds of apps are being developed, and the advances in technology lead to the development of technology that contributes to the rapid doubling of human knowledge. Futurist experts estimate that in 2020, now, human knowledge doubles every 12 hours. Second, softwares and apps are mainly designed for business, not education. This means that students are learning how to use the program or tools and not learning the content of the class. And third, the situational nature of the class. A teacher can adjust a lesson to make sure it meets the needs of the specific group of students, but the technology cannot do this. Although there are new adaptive technology, it still cannot replace the judgment of a teacher. The fourth, the emphasis is on what and not how. This means that the lesson becomes about what technology are we going to use, what does it say, what skills does it require, instead of how can I teach my students. Now, this figure shows the TPCK framework proposed by Mishra and Kohler. The framework highlights the dynamic interplay between and among the various components of teacher knowledge in terms of technology, pedagogy, and content. And the framework identified 3 primary forms of knowledge that a teacher must combine. So there's content knowledge, there's pedagogical knowledge, and there's technological knowledge. And the center of the diagram, otherwise known as TPCK, represents a full understanding of how to teach with technology. This framework was developed to explain the set of knowledge that teachers need to teach their students a subject, teach effectively, and teach with the use of technology. Now, keep in mind that this is not the same as having knowledge of each of the primary concepts individually. So aside from understanding each components individually, it is also important to look at these components in pairs and 3 taken together. The point of TPCK is to understand how to use technology to teach concepts in a way that enhances student learning experiences. The assumption here is that when teachers teach with technology, there are three elements that interact, forming several knowledge intersections. So when we talk of pedagogical knowledge or PK, it describes a teacher's deep knowledge of the practices, processes, and methods regarding teaching and learning. And as a generic form of knowledge, PK encompasses the purposes, values, and aim of education and may apply to more specific areas, including the understanding of student learning styles, classroom management skills, lesson planning, and assessment. The question you should address here as a teacher is how does your student learn best, and what instructional strategies do you need to meet their needs and the requirements of the lesson. We also have technological knowledge or TK, which describes teachers' knowledge of and ability to use various technologies, technological tools, and associated resources. It includes skills on how to use or operate certain technology. The question you should address here as a teacher is what digital tools are available to you, which do you know well enough to use, and which would be most appropriate for the lesson at hand. And then, of course, there's content knowledge or CK, which describes teachers' own knowledge of the subject matter. It may include knowledge of concepts, theories, evidence, and organizational frameworks within a particular subject matter. It may also include the field's best practices and established approaches to communicating this information to students. This will also differ according to discipline and level. For example, physics freshman students require less detail and scope than those already taking major subjects. The question you should address here as a teacher is what are you teaching and what is your own knowledge of the subject? Now, you also need to combine both knowledge in pairs. So we have pedagogical content knowledge or PCK, and it has to do with a teacher's knowledge of how his or her subject matter should be taught. So for example, if you're a teacher of biology, you must have this pedagogical content knowledge so that you would know how your particular subject matter should be taught. It focuses on promoting learning and on tracing the links among pedagogy and its supportive practices, such as curriculum, assessment, etc. And there's, of course, the pairing of technology and content, which is technological content knowledge, or TCK, which refers to knowledge of how the use of technology impacts on the subject matter, including how it is represented, organized, and learned. It involves understanding how the subject matter, for example, you're teaching math, how that particular subject matter or topic in math can be taught through the use of appropriate technology, which is best suited for specific subject matters. So like, for example, you're teaching formulas and equations. So what kind of technology would be appropriate for you to be able to teach that particular subject matter effectively? And then we also have technological pedagogical knowledge, or TPK, which is a combination of technological and pedagogical knowledge. It refers to knowing what technology to use for a particular teaching task, knowing how to use a particular technological tool to achieve a particular learning outcome or set of outcomes, and knowing what pedagogical strategies are appropriate and effective, and using technologies according to these strategies. And of course, we have the combination of all of these elements, which is called the technological pedagogical content knowledge, which combines all of these types of teacher knowledge. So ideally, this is how you should be doing as a teacher, Because TPCK requires an understanding of the representation of concepts using technologies, pedagogical techniques that use technologies in constructive ways, teach content, knowledge of what makes concepts difficult or easy to learn, and how technology can help address some of the problems that students face, knowledge of students' prior knowledge and theories of epistemology, and knowledge of how technologies can be used to build on existing knowledge and to develop new epistemologies or strengthen old ones. Now, in order for teachers to make effective use of the TPCK framework, it is important that you should be open to key ideas. So you should be open that concepts from the content being taught can be represented using technology. Should also be open that pedagogical techniques can communicate content in different ways using technology. And it is important to understand that different content concepts require different skill levels from students, and technology can help address some of these requirements. And students come into the classroom with different backgrounds. So some of them will already have prior learning, and many of them with a different range of exposure to technology. Especially now that our students are digital natives, so they are born in the world where everything is already digital. So they have a different way of learning, they have a different way of understanding things, and they have a different way of interacting with technology. And of course, you should also be open that technology can be used in tandem with students' existing knowledge, helping them either to strengthen prior epistemologies or develop new ones. Okay. Now, let us talk about emerging and key trends in technology. As discussed earlier, during the earlier part of my talk, COVID-19 has become a catalyst for technology adoption and digital transformation, and will greatly accelerate several major trends that were already well underway before the pandemic. Now, let me discuss here some of the emerging key trends post-COVID-19 scenario. First is that there will be a rise in blended learning and personalized education. So during this pandemic and even after the pandemic, a lot of teachers and parents may prefer to reduce the physical attendance of their kids at school and will opt to do blended learning and personalized education. There will also be a number of parents who will be exploring homeschooling as an alternative for sending their kids to school. There will also be a move to apply the shifting of classes to maintain physical distancing, which will necessitate schools to do flipped learning in order to maximize physical contact at school. Now, second trend is the online internationalization. In the short term, so this is post-COVID-19, which probably will happen in a year or two or three, international student mobility will decrease due to health risks and some problems with student visa. And international visiting professors could teach their courses online, continuing to provide some internationalization at home. So visiting professors such as models such as this one would be increasing in the coming years. So instead of inviting foreign professors to come to Jember University, there will be more online internationalization, more international professors teaching online with the university. Then the class will go from social to asocial. Friendships, campus bonding, and huddles will be on hold for a while, and invisible walls will come up, diluting in many ways the fun and euphoria of campus life. This will be, of course, replaced by strengthened social networking and online platforms for social interactions. And since sports will be in low gear for a while, popularity of esports will rise and other collaborative gaming that integrates physical movement and interactive games. And fourth, social distance may lead to some getting socially distant. With the prominence of technology in teaching, inequality will sadly widen, with those more well-off families able to buy more expensive and more powerful gadgets and tools, which will invariably shape the students' confidence in virtual classes. The underprivileged would most likely always be the meek attendees who would feel afraid to say something wrong in the virtual class, hence would prefer silence over participation. Such inequities will be more prevalent with more well-off students able to participate online, while those who cannot afford modern technology will be relying to offline classes. And fifth, um, there will be a change in the role of teachers. We have been saying this in the past decade or so, but we have not really seen a major shift in the role of teacher. But the notion of a teacher or an educator is a knowledge holder who imparts wisdom to pupils or students will no longer fit for the purpose of the future. With students being able to gain access to knowledge and even learn a lot of technical skills through a few clicks on their phones, tablets, and computers, we really need to redefine the role of teacher in the classroom of tomorrow. This may mean that the role of teacher will need to move toward facilitating students' development as contributing and employable members of society rather than just as lecturing. Okay. Another key trend is teaching will go more high-tech yet experiential. Technology companies will be competing for that market share to offer new technology beyond video conferencing like the one that we are doing. The demand will be for more work-relevant courses or learning paths and learning experiences that prepare students for artificial intelligence, augmented reality, virtual reality, mixed learning, blockchain, big data, cloud, data analytics, voice deployment, and more. We will see a significant thrust towards experiential learning as well. And seven, technology alone is not enough to be the enabler. There should be policies and laws in place as well as structured plans and collaboration among various stakeholders. And eight, technology will be about the content, not just the container. It is possible to become so enamored with the technology and distracted by device-related and delivery-related questions that insufficient attention is then given to how to use whatever devices are eventually deployed to their full effect, which is why I have highlighted the dynamic interaction among technology, pedagogy, and content. And nine, online learning courses will be the mainstream education. With the experience everyone had with the pandemic, more and more schools will be developing online courses. And 10, AI, artificial intelligence, cloud computing, 5G networks, cybersecurity, and blockchain technology will continue to accelerate. This technology were already underway before the pandemic, and the COVID-19 crisis made us realize how ill-prepared many of us in handling the situation from health, economy, and education. Now, with all the promises of technology in the coming years, let me just go back to the basic principles of an information society and knowledge-based society to remind us that as we move forward, we should always be aware that advancement in technology per se is not enough. Technology must be able to bridge the persistent gap between the global north and global south, the haves and the have-nots, and must be a catalyst for economic and social development of countries. In an environment where information and knowledge are crucial to social and economic development, we must always ensure that there is universal service and universal access, meaning access to information, and the means to use that information needs to be extended to everyone, everywhere. There should be access to information and knowledge, which is essentially determined by connectivity, capability, and content. Which must, we must ensure that there is equality of opportunity as well as equity. Each country should also promote measures to help people of every age, background, and location and level of physical ability to access ICT. And countries should actively involve the youth in national and regional ICT activities, ensuring better gender balance in ICT use while instituting specific programs that address the need of women, particularly those aimed at rural and disenfranchised areas. And we must ensure that there is content diversity. Um, as it is now, content is largely in English. If you look at the content on the internet, content is basically in English. Content is a fundamental element for the utilization of ICTs, and development of local content on the internet is a means to ensure a culturally and linguistically diverse cyberspace. And this diversity is also an important part of our cultural heritage and has to be protected. ICTs provide new channels for the expression of this diversity and for the worldwide dissemination of locally created content. Diversity of content on the internet would enable the participation of all and ensure sustainable access, realizing the full potential of the internet as a source of information and knowledge. Appropriate content would also benefit the utilization of ICTs for educational purposes, training, and human resource development. And of course, lastly, freedom of expression and freedom of access. Communication can be a vehicle for the implementation of the principle of freedom of expression. And this is in the United Nations Universal Declaration of Human Rights. Everyone has the right to freedom of opinion and expression. These rights include freedom to hold opinions without interference and to seek, receive, and impart information and ideas through any media and regardless of frontiers. Now, for the continued development and creation of the global information society, it is essential to safeguard plurality of opinions and to promote open access to networks for service and information suppliers and free expression of ideas. This information should be coupled with the right of the public to have access to information which is disseminated in all media, including our new digital multimedia system. Okay, now to end my presentation, let me just say that the disruptive and transformative nature of technology offers tremendous opportunity to ensure continuity of education. The pandemic has offered us an opportunity when it becomes a catalyst for technology adoption and digital transformation. It is now up to us how to sustain the momentum and to ensure equity and quality in education through the use of technology. Thank you everyone for listening, and thank you for inviting me to this international conference on physics and mathematics for biological sciences.
Okay, thank you for the outstanding presentation, Dr. Sarah. Very well, ladies and gentlemen. Now we come to question and answer session. Please press hand icon to ask question and also mention your name and institution before the question. Or you can also deliver the question by Zoom chat features. Okay, any question? question?
The question is question. Is this question? Saya tanya nanti harus nungguin.
Okay. Okay, we are still waiting for the question. Dr. Sarana, I ask your permission to share your presentation to all the participants of this conference. Is it okay?
Yes, please do share. I sent you a PDF copy of my presentation.
Oh, okay.
And I think the presentation is recorded, so they can just listen to it later again.
Oh, okay. I think there is still no question, but as Professor Bardilov before, we still open our chat or our email to have your question, and we will deliver it to the presenter. Thank you very much for Dr. Sarano for joining our conference and present your ideas.
Thank you.
Ladies and gentlemen, finally we come to the end of the presentation. We would like to say thanks again for all the presenters, for the informative and the interesting talk, and to the audience for your active participation. Hopefully, the presentation will be beneficial for everybody. The last for me, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Okay, thank you very much, Mr. Iqbal, for guiding us to hear or learn some insight from Professor John. And now we reach in the next session with the two last speaker. Speaker will be led by Mr. Aditya Kurniawan, SSE and Biomed. Yes, Mr. Aditya Kurniawan will lead the next session. He was graduated from University of Gajah Mada in Master of Biomedic. For Mr. Aditya, could you please come forward to guide us? Okay. For all the participants, thank you very much for staying tuned with us. And this occasion we have the third speaker from India. It is Associate Professor Ramesh Nachimutu. And I will let Mr. Adit to guide us. Mr. Adit, thanks yours.
Okay, thank you, Mrs. Pia. Good morning, ladies and gentlemen. Let me introduce myself. My name is Aditya Kurniawan. I'm the appointed moderator for this event, the second international conference on physics and mathematics for biological science. Now it's time to start our third presentation. Associate Professor Ramesh Nachimutu, PhD from Fellow Institute of Technology, India. He is working in the field of medical microbiology, especially antibiotic resistance and bacteriophage therapy for past 15 years, and social activist in IIMAR by creating antimicrobial resistance awareness program, also initiating bacteriophage research and therapy in India. He completed one PhD short project, two consultancy projects, and having 11 international collaboration. Before we start the presentation, let's know the regulation of how the presentation will be going on. Each speaker will have 30 minutes to deliver the presentation. Then will be continued by the Q&A session for 10 minutes. Please mute your audio so we can hear the presentation clearly. Okay, Prof. Nachimutu, time is yours.
Yeah, are you? Is my audio okay? Shall I continue?
Yes, I can hear you clearly.
Thank you. Thank you so much. I thank Dr. Dafik and his team for conducting excellent international conference at the University of Jember, Indonesia. So I'm very happy to part of this conference. So today, I'm going to discuss about the therapeutical characterization of bacteriophages for against carbapenem and collusion resistant Enterobacteriaceae. So this is my field of interest. I used to do research in the field of antimicrobial resistance and bacteriophage therapy. So nowadays, we lost all available antibiotics in the world because of overuse, misuse, and improper use of antibiotics. I hope you all know what is antibiotics, what is the uses of antibiotics. So without antibiotics, we cannot even go for any, for operation or any other thing, organ transplantation or anything. So therefore, we need to have a potential antibiotics in our hand before start to any treatment. So nowadays, as I pointed out earlier, because of this overuse, misuse, and improper use, so throughout the globe, we are now suffering for new antibiotics. So that is the reason behind I'm just started my research, and I just finding out alternative method for this antimicrobial resistance. The bacteriophages I just planned in the year of 2008. Actually, it was 100 years back we were using it. So now again it given attention for these bacteriophages. So the synopsis. So what is the AMR research in our work? Okay, so how phages are developed in our lab for treating the bacterial infections, our lab and the team behind the research, our collaboration and acknowledgement. So the objective of research is we work in guidance provided by the WHO, international regulatory bodies such as WHO and FDA. So we aim to provide a solution to the infectious disease, and then we strive towards the betterment of the mankind. That is our aim and motto. So the awareness, the aim or antimicrobial resistance in the GAP, Global Antimicrobial Resistance Partnership. So through the greater interactions with the communities and the healthcare providers, surveillance through continuous collection of quality data and its analysis, the reducing disease burden, that is very important. So through immunization, nutrition, infection control practices, so optimization use of antimicrobials through the standard treatment guidelines, quality drugs, and their rational use. So the investment, research, and innovation through the utilization of UHC resources and availability of the field of area. So our aim of research. So in our research laboratory, so we have more than 2,000 clinical, pathogens, especially the clinical pathogens. We have gram-positive and gram-negative from South India, okay, and also we are getting the isolate from the Mizoram, North India. So our first step, the clinical samples isolation identification, and then resistance screening and the MIC determination, resistant genes, plasmids isolation, and then mobile genetic elements, and then conjugation. This is the steps what we do as soon as we collect the isolates. So our lab studies, so we are isolation and identification of cephalosporin resistance, carbapenem resistance, collusion resistance, tricycline, MRS, and MSSA resistance. So we are finding out this resistance from the clinical pathogen. So these are the samples. We used to screen this is the antimicrobial, the resistant gene resistant genes. So in our lab, we used to screen this NDM, oxacillin, KPC, IMP, AIM, BIC, DIM, SIM, WIM, CTXM, GS, OXA, MEXI, MECA. So these are the resistant genes we used to screen with the clinical pathogens. So far we did 79 genes were screened under the CTXM gene, and 38 were screened NDM1. So these are all the resistant genes. So we have isolated from and amplified from the clinical pathogens. So the carbapenem resistant genes, so present in all the isolates we have seen, and we did 16S RNA sequence and then integrant sequence. So this all fully deals with the screening of antibiotic resistant genes from the clinical pathogens. So the prevalence, okay, this is the study we did and published it. So the prevalence of NDM among gram-negative bacterium from clinical samples of Tamil Nadu, So the study aimed at determining the ability, antibiotic susceptibility and prevalence of NDM in clinical samples. So you can see this is the diffusion test based on the antibiotic sensitivity pattern. So see, you can see the meropenem. So it's 98% resistance and meropenem, cefotaxime, cefepime. So these all antibiotics. Okay, so resistant to the antibiotics. Yeah. So we have screened. Okay, we have screened the NDM. So 50% prevalence of beta-lactamase NDM1 in Salmonella species in our study area. So the plasmid profile and the molecular direction of NDM. So we just find out the NDM gene from the isolate. So the molecular mass of each strain was compared with the reference strain, and profiling was carried out. Plasmid profiling was carried out. E. coli had a very it's a varying range. There's of size from 20 to 60 kb with more than 2 plasmids. Each bacterium has the 2 plasmids. The 4 strains of Klebsiella pneumonia had plasmids ranging from 50 to 60 kb with the 2 plasmids. 2 strains of Salmonella typhi and 2 Acinetobacter baumannii had 3 plasmids each, and 1 each of the Stenotrophomonas. So the plasmid identification of plasmid is very important here, because the resistant gene is transferred one bacterium to other bacterium through the plasmid. So that is why we focus to whether the bacterium has the plasmid or not. So the another study, so we did screening of cefotaxime type extended spectrum beta-lactamase producing clinical isolates from Tamil Nadu, India. So the study aimed at determine the ESBL production and the presence of cetexem of clinical isolate collected from tertiary hospital northeastern part of Tamil Nadu. So the antibiotic susceptibility pattern showed 92% of the isolates were resistant to beta-lactam antibiotics. That is very important here. So you can see the each and every the back E. coli has given a more than 30% of resistance. Okay, so like that. So we tested the cefotaxime resistance, since it is the third generation cephalosporin. So we need to find out. The total of 29 isolates were found to have a cetexem group genes, group 1 genes, that include E. coli 53%, and then Klebsiella pneumoniae 40%. So the gene sequence was submitted to GenBank. Okay, so all the genes whatever we have screened, it is submitted to the GenBank. So the antibiotic susceptibility test result with 9 different beta-lactam antibiotics placed over MHR with E. coli and then Klebsiella pneumonia. So left and right. So the multiple species amplification of cefotaxime group genes. So LAN 1 to 11 with clinical isolate positive for the cetexem group 1, and the last one is the DNA molecular ladder. So the characterization of carbapenem resistance in gram-negative bacteria. So this is another study we did to identify the carbapenem resistance among clinical isolates from Chennai and Trichy in Tamil Nadu, and then the gene screened, the beta-lactamase oxygen, and then NDM and VIM, imipenem, and KPC gene. So this is we have screened, and the MIC 1590 were calculated, and SN 0.12 and 16 mg per ml. So out of 93 isolates, 16 carried NDM, which includes 19 E. coli, 4 Klebsiella pneumoniae, and 2 Enterobacter baumannii, and 1 Provincial degree. So these are the results we got from the study. And another study we did the distribution of carbapenem and colistin. See why we are focusing this, the carbapenem and colistin. So this is the last resort antibiotic, okay, of this regimen. So once we got a resistance to this kind of antibiotics, so we don't have any other alternate option. That is why we focus on screening only the last resort antibiotics. So aim of the study is to determine of carbapenem and colistin resistance in regions of Tamil Nadu, and screening of carbapenem resistant genes MCR1 and 2 and integrants were studied. The MIC testing showed that out of 58 out of 89 and 29 out of 89 isolates were resistant to meropenem and colistin. So this is the more important studies, and the class we also screened the class 1, 2, and 3 integrants were detected in the isolates studies. So all this, whatever we just amplify, it is just sequenced and submit to the GenBank. So this is the another important study from our cetexem, the genetic characteristics of plasmid-mediated ESBL and its coexistence with carbapenem-resistant clinical isolates. So the study was carried out to determine the presence of ESBL resistant gene, cetexem, and carbapenem resistant. So the transconjugation and DNA fingerprinting. So the transconjugation is nothing but just whether we just tested whether the resistant gene is transferred to one bacterium to other bacterium. Okay, so the MIC showed 77.6% and 36% of the clinical issues were resistant to cefotaxime and meropenem. This is the high impact. And then the beta-lactamase cetexem was present in 34 isolates, and NDM1 present in 6 isolates, and oxo-48 in 2 isolates. So the class 1 integrants in 22 isolates and the class 2 in 5 isolates study. This is a very notable study result. So you can see the highest resistance was observed in E. coli among the pathogens. So we observed highest resistance in E. coli. Okay, so it is very the cefotaxime and the immunopen resistant isolates as distinguished in the study. So it's very notable things. So another things, now the inhibition of BLA-DIM1 in beta-lactamase gene in Pseudomonas aeruginosa. So the aim of the study was to determine the genotypic pattern of beta-lactamase C-texum. So it's a group gene, complete 1 to 8, 9, 25, and amino glycoside resistance, ASC, and then the mobile coalition resistant genes we screened. So the study showed the presence of beta-lactamase DIM1 gene in Pseudomonas aeruginosa strain. So just we have seen, our target to isolate the variety of clinical isolates, the samples, and then from that we used to characterize the different type of resistance. That is very important. We need a prevalent study. We need prevalent data. Therefore, we did the study and we find out the maximum, minimum, the small things to the higher level. We need to report it. We need to whether the location, geographical area has this resistance or not. So so this is the, the also highlights the DIM1. Okay? DIM1 was found to share homology with other carbapenem genes such as 43% with the IMP types, 52% with GIM1, 32% with the SPM1. So these are the resistant genes. Okay. So and another important study, since we nowadays know all the digitalized. Okay. So whenever we used to go to anywhere to we need to access the digital keypads. Okay, digital keypads and laptop, mobiles. Okay, and we may use the common transport systems and bus, trains, and flights everywhere. So this is the first study we did in India. So we find out the the prevalence of multi-drug resistant strains on touch screens of automated teller machines. So here to determine the MDR bacteria from inanimate surface such as metallic keypad and touch screens of ATM machines, antibiotic susceptibility testing with ampicillin, cefotaxime, ceftriaxone, ceftazidime, and meropenem. So the resistant gene screening, NDM1 and C-texum gene screen we screened. Isolate studies showed resistant to more than one antibiotic tested out of 120 isolates. So 46 showed resistant to cefotaxime and meropenem. So means, so when you are going to test the screen, okay, obviously we'll get a pathogen from the any type of screen. So this study highlights the possibilities for the presence of other type of ESBL, okay, showing the prevalence of MDR bacteria in ATM centers. So, as I told you, the other strains, the 46 isolate were amplified the NDM1 C-texum gene. So the study highlights the possibilities for the presence of other type of ESBL, showing the prevalence of MDR in autoteller machines. So we decided, okay, why don't we find out, since the currency is handled by everyone, there is opportunity to get this, the bacterium on the surface of the currency. So we decided to do the study. So the bacterial load and contamination of Indian currency notes, isolation and transferability studies of MDR bacteria. So to determine the prevalence of MDR in a Indian currency notes from major regions of India, with Tamil Nadu, Karnataka, West Bengal, Assam, New Delhi, and Gujarat. So rupees note we collected 10, 20, and 50. The total of 75 bacteria was isolated, which includes Bacillus, Streptococcus, Staphylococcus aureus, E. coli, Klebsiella, Pseudomonas, and Salmonella. So the multi-drug resistance was observed in 43% of the isolates. Okay. So and the presence of the beta-lactamase C-texum, 3 isolates were found to involve the conjugative transfer. It transferred resistance to other bacterium. So F- strains. So the after so far I just shown the results from the AMR, antimicrobial resistance. Now I'm going to share you the phage therapy. So what is the bacteriophages? So bacteriophage is nothing but it is the virus that kills the bacteria. So we just we were 100 years back we were using the bacteriophages as a therapeutic option for the bacterial infection. So as soon as we find out the penicillin in the 1941, we just stopped using bacteriophages. The whole Soviet Union they were using it. Still the Georgia they are treating the patient using the bacteriophages. So our target, okay, we need to find out isolate and characterize the bacteriophages against to pan-drug resistant, multi-drug resistance and pan-drug resistant clinical pathogen. So just we'll see it. So these are the papers we published in bacteriophages. Okay, so we published in a Frontiers in Microbiology and BMC Microbiology. and then plaston and scientific reports. So bacteriophage, you can see the bacteriophages. Okay, this is the plaque formation. So when you grow, when you introduce the phages on a surface of the bacteria, the lawn culture of the bacteria, okay, just it forms a, see, you can see the complete plaque formation, nothing but just lytic activity, just kill the bacteria. Okay, so it's simply, it's the method called as double agar overlay method. Okay, you can see the part. So also when we need to find out the bacterial life cycle. So what is the absorption time, and then the latency period and the birth sites. Okay, this is very important. So the absorption time, okay, it takes 25 minutes to absorb, and then the latency period, it takes another time to just once it attached, it just go inside and get the enzymes of the host, and then assemble everything, and then just comes out. Okay, that's called a burst size. So this is the complete characterization of the phages. So first we need to go for a term analysis, okay, and then so we find out our the EC 131 PSK is the myviridae, and then the KP 1326 PSK belongs to cipoviridae. So this all based on the term analysis, term morphology analysis. We just find out based on the the techniques used, and then the DNA size, either 18,000 base pair and 22,000 base pair, respectively, the thing. So we need to do one of protein, viron, and then mutation frequency, find out, and the absorption velocity, how long it takes, and then the latent period, and then burst size. So how many bacteriophages will comes out once it attacks the host, and then the pH and temperature. So these are the very important studies of the phages. So once to isolate the bacteriophages, it should be all the basic studies need to be done, and then the efficiency of the pages need to be done, and then we have to go for a further study. So this is our pages. We just analyze using the TEM analysis. So Echerichia phase, so so belongs to cipoviridae, and then a Klebsiella phase belongs to podiviridae, then Enterobacter phase belongs to myoviridae. So it's all the analysis, and it shows the phylogenetic tree analysis of E. coli phage, and their protein based on genomic sequence of selected phages on an NCP blast. So we find our pages resembles with the other pages. Since we have in E. coli we have two pages, and here the same. So the genome sequence, we did a whole genome analysis. Okay, we did a whole genome sequencing of our 4 bacteriophages. So it it's the image shows this. This is our own pages in this right side. The left side is so it's matched with other pages available in NCB. So so once we find out, once we got the bacteriophages, so it needs to be tested. Okay, whether it's in vitro and in vivo. So in vivo we need to use animals. So rather than using animals, we just use the Galleria melanola. It is a wonderful infectious model. So we used and we used this Galleria melanola, and we just injected our bacteriophages in the prolog, last leg prolog. So this is the model we planned. Okay, we planned for yeah. So set 1 we made 4 different sets. Or set 1 control on saline, and then set 2 is control bacteria alone. Then set 3 control on phage only, and then test set 4 is the test. So here we further divided into a single dose and the multiple dose. So infected with bacteria at the concentration of 10 to the power of 8 colony forming unit per ml. Okay, and then treated with the single dose phage. So the phage concentration was 10 to the power of 4 plaque forming unit per ml. Okay, this is a single dose. So here again we tested and gone for the multiple dose. So infected with bacteria 10 to the power of 8 CFU per ml. The treated with the multiple dose of phages and the concentration of 10 to the power of 4 plaque forming unit per ml at the 0th hour, 6th hour, 12th hour, and then 24 hours. We just tested. Okay, so this the graph shows that. So the impact of E. coli phage, okay, treatment on G. melanola, so larval survival. So here treated with single dose, okay, and then you can see as soon as given the first dose, it takes it will be there until 48, and it treated with multiple dose, so we got until 95% the survivability. So that is why we just increase the number of doses. So also the phage, the concentration of the phage is also very important. Okay, once it goes inside, just can keep on doubling it. So the phage cocktail. So what happens? Some of the patients may got infected with more than one bacterial pathogen. So in that case, we need to find out, we need to mix the phages. Okay, for example, since the bacteriophage is this genus specific, it will not kill any other strain type or genus type. Okay, just find out only the specific strains. So we plan to mix the phages together and then just inject it to the Galleria Manila. So we got a wonderful result in this case. So the in vitro phage activity of prepared phage buckets, here we got a it just killed all the pathogen which is present in the patient's body. So on the studies we did a lyophilization. So lyophilization is very important. For example, now it's a globalization. Throughout the globe, we may need to send this our pages, since every part of the scientists are working in all part of the globe, and they may exchange the pages. So it's not possible to exchange the pages and send the pages through the liquid media. Okay, therefore we plan to go with the lyophilization. Okay, and we made a powder. We made different excipients. Okay, so among that, the sucrose and gelatin had a excellent it gives the stability of the bacteriophages. So our concentration is we were looking at stability, which chemical composition is going to give a good stability. So we made a sucrose and gelatin combinations, gave a high stability. So we further move on and we went for a patent application. So these are the list of peer-reviewed papers we published so far. So as I told you earlier, in India we have the people must aware of antibiotic resistance, how to consume the antibiotics. They don't know the difference between antibiotics and other medicines. Therefore, we started an NGO in India. So this is the site and social media link. Our main motto is to create awareness to the peoples, the publics, the India. So they must know. So what the clinicians do, what the pharmacists do, what the common people do. We made a brochures, and we every year we used to conduct the program throughout India regarding the antibiotic resistance. Okay, so I just shown these things. Last year when I was with in your campus. So this is the program. So I just attended in India. So last year I'm happy to be with your family. Dafik and my friend and all this team, Ivan. So I was it's very excellent moment when I was with you. So this time, because of this pandemic, we cannot meet. So I hope this condition will now move away. So these are my collaborators around the globe, my research teams in India. So thank you so much for your wonderful conference, opportunity given to me. Okay, thank you all. Thank you once again. Thank you so much.
Okay, very much. Thank you very much, Prof. Netrimutu, for an informative and interesting presentation about multi-drug resistance in bacteria in multiple surfaces such as ATM machines and community. And this presentation also show how we can fight drug resistance using bacteriophage. I believe that our audience starts to develop concept and ready to ask you a question. I will give the opportunity to 3 participants. You can use the raise hand feature on your screen, or you can type your question in the chat room. Anyone? No question? Okay. I think there's no question from the participants. Thank you very much, Dr. Ramis Nikimutu. I'll glad you to come again to Indonesia. Thank you very much, Dr. Ramis.
Thank you.
Okay, and we move to Prof. David PhD. Prof. David PhD is the Dean of Faculty of Teacher Training and Education. He concerned in educational technology, graph theory, combinatory, discrete mathematics, and applied mathematics. For Prof. David, time is yours. Prof. David.
Yes.
me have 1 minute for preparation.
Okay. We go to the MC.
Okay, thank you very much, Mr. Adi, and thank you very much for Professor Rones. Such interesting presentation for this.
So I'm ready. I'm ready now. I'm ready now.
Okay, just a moment. Okay, I will give to Mr. Adi.
Okay, thank you. And Prof. Natif, you can start now.
Yeah. Good afternoon, everyone. Please allow me to share my slide presentation. Yes. As mentioned by moderator, I'm working a lot on combinatorics and graph theory, but later also I'm working on combinatorial education. Now, our conference, apart from talking and discussion about the basic sciences, and now also we would like to share the application of basic sciences in education. So our title is The Students Combinatorial Thinking Skill under the implementation of research-based learning to develop a secure crypto system by using super edge anti-magic total covering. Sorry, it's a bit longer title. So there are three things in this title. The first one is combinatorial thinking, which is considered higher order thinking skill. It is also required to survive in the 21st century era. The second thing, we have a model of cooperative learning models, namely research-based learning, which is currently applied in my university. And also we develop not only in process standard, also in the curriculum, and we call research-based curriculum. And the final one, we have a problem, how to develop a secure crypto system by using anti-magic total covering. So I have research achievement so far. We have more than 140 Scopus publication, bachelor degree, master degree, doctoral. I am working on combinatoric and graph theory. I was graduated in Federation University that Professor Adil now teaching there. Okay, the previous result on this current topic, we already has a publication as well in the Scopus journal, either in the proceeding or in the public journal, regular journal. So, what is actually the crypto system? It is a main concern in our research. The crypto system is a system which convert plain text to ciphertext. In the crypto system, we have implemented the application of encryption and decryption algorithm. Normally, the strength of crypto system rely on the management of encryption key. So the keys should be managed as good as possible, such that it is hard for any intruder to analyze or to reveal the key. That's the main thing in the crypto system. So I believe everybody of participant know well about what is the crypto system. Normally, if you are working on the information and technological sciences, in crypto system we have encryption and we have decryption. Normally nowadays era, as Professor Joanna Serrano say, there are a lot of the use of Internet of Things. I believe when we use Internet, we should guarantee, we should ensure that the channel that we use is secure from, especially from the hacker or from other unauthorized people. So that's why encryption technology now is important. What is encryption technology? The encryption is the process of transforming information so it is unintelligible to anyone but the intended recipient only. What is decryption? The process of transforming encryption so that it is intangible again, so people can understand after revealing the key. So encryption process normally proceed the plaintext, become the ciphertext. There is interface that we call encryption. And now from ciphertext into plaintext again, there is interface that we call decryption. So both of them need a key system. And we are working how to secure the key system. We already have a publication and books and writing a monograph about this kind of thing. And in our research, we implement the use or the application of combinatorics and graph theory into a modern crypto system. I just give you an example how the illustration of modern cryptograph by using a graph. For example, if you send a text or message to other people, I have a sentence here, Madam, I'm Adam. How this text sent to other recipient, to the other people mobile phone, for example. When you send that text from your mobile phone to other people mobile phone. Do you think the text fly on the air and get into your mobile phone? Or do you think difference? So how was it done in terms of a crypto system? The crypto system firstly convert the plain text into ciphertext using encryption key. So how do we generate the encryption key? Normally we tabulate the character first of the plain text. So when you consider Madam, I'm Adam, of course we have M as the first character, A is the second character, D is the third character, comma, space, and also I, apostrophe, and full stop. Of course, how many characters there? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 characters. Now, by using a binary tree, so when we have a 8 character, using binary tree is a tree in a graph having 2 branches.
that's going down. So in the two branches, we label 01010101. That's a binary. And we have a prefix code after that. So how to generate the prefix code? At the bottom level, we try to put the character that we already tabulated before. We have 8 characters, M, A, D, I. It is in sequence as the character appear firstly. If the M character first appear, and then we put M at the beginning. M, A, D, I, comma, space, apostrophe, and full stop. And how to have a prefix code? So for M, we have a prefix code 000, and then we have M. And for A, we have 001. We have 001. So by using these code words, and we have the ciphertext of the Madam, I'm Adam, with this following ciphertext. So you can see here, 000. Of course, it is not readable by the human being. It is only readable by the machine, the computer or the mobile phone, your gadget and everything. So this is a ciphertext. So this is encryption process from the plain text, Madam, I'm Adam, into into a ciphertext. So when this ciphertext send and getting into your mobile phone, and how the mobile phone decrypts such that the ciphertext can be readable again by a human being. So that's decryption. Now, consider here, if we use this one, and then we have this one, the total code word is 48-bit. You can count 0007 until at the end of the code word. 1 byte is 8-bit. So there's the plain text need 6-byte storage space. In the crypto system side, we not only consider how to develop a secure crypto system, but also how to slow down, how to minimize the storage. Now, this one also the second concept. So that's why there are a lot of binary code algorithm. The latest one we have a Huffman binary code algorithm, not only using binary tree. In this research, I try to implement the super H anti-magic total graph to be an encryption key in the crypto system. What do I mean by super ADH anti-magic total graph? So this is the definition. I don't want to go into detail to read this definition. I believe you can see in the screen. So, but I can give you the resulting of super H anti-magic total can be potentially generate a complex key. So I just said that complex key in the crypto system is important. Otherwise, the unauthorized people can reveal, can introduce the key in such way they can do for betting, for example, like carding. So when you input the number of your card, a credit card, to have online transaction, online purchasing, for example, they use the platform, of course, use a secure crypto system. But this one, I just endorse to use graph theory, especially graph labeling. So in the crypto system. So what is the super H anti-magic total graph? So this is just an example of a cycle graph. For example, here, the red dot is the evaluation. The first one, we evaluate 2 adjacent vertices. And the second one, we evaluate not only 2 adjacent vertices, as well as 1 connecting edges. And the third one, not only 2 vertices, but 3 vertices, as well as all the connecting edges. For the first case, we just call ADH anti-magic total, ADH anti-magic labeling. For the second case, we have ADH anti-magic total labeling. Now, in this research, we use ADH anti-magic total covering because the involvement of the vertices, not only 2, but 3 vertices at least. So that's why we call cover. In Indonesia, we call sleep. So we call cover. I believe some people also working on this. Now, for the bigger number of order, we have yeah. Sorry, moderator. Someone also. Yeah. Can you? Okay, I just said. So this is the another example. So this is the cover. And this is the cover is C4. The previous one is C3. Now we have a C4. Yeah. And that's we call super H anti-magic total labeling or total covering. Now, in education side, what is the type of the research and study? When we are talking about mathematical sciences, normally mathematics scientists develop an algorithm, develop a theorem, develop a lemma, develop a corollary of whatever, like Pythagorean theorem, for example, like also four-color theorem, for example. And there are so many applications behind that, of course. Yeah. But when you are talking about education side, I believe now we are trying to explore when our students are taught about super H anti-magic total covering and the application into the crypto system, for example. How is their higher order thinking skill? Can we examine their thinking activities? So this is also another side in education. So that's why we try to have a new terminology, which is also published by some other people, that we have a combinatorial thinking skill. So in this case, we will give you what is the combinatorial problem. Combinatorial problem, actually, the first one is we should answer the question, does the solution exist? The student should have a thinking process to ask a question about the existence of the solution. Then secondly, if the solution exists, how unique are they? So actually in the education side, we have open-ended problem, multi-technique, multi-solution. So if you find out the solution, and then you just satisfied with the solution, then you don't have a combinatorial thinking skill. If you have a solution, and then the question further rise, how unique the solution? Is there other solution apart from this one? Then in your mind, you already established the combinatorial thinking skill. And then if you have a answer about the second question, and you find out the solution, and then your question again rise, how optimum are they? This is the combinatorial problem, and also the combinatorial thinking skill indicator. And can we generalize this one? And the second one, the last one, can we prove it? So in mathematics science, we never believe to the existence of the rightness that's generated from inductive cases. Normally, we try to have a deductive cases. Even we use inductive, there is a mathematical induction, which is a very formal mathematics. From certain cases, extend to other cases, extend to third cases, and we try to have n cases. Now, if we compare this one into the 21st century scale, exactly we can have this one. When people ask about the solution, they already have innovation thinking skill. When people ask about the uniqueness about the solution, and they are thinking about the creativity. If people thinking about is this optimum, they are thinking about the critical thinking skill. And then can we generalize? This one need to have a collaboration skill. And then we can we prove it? Then this one also part of the 21st century skill that we call communication skill. Now we try to confirm this one, which combinatorial thinking respecting to Bloom taxonomy. I believe they are in the top level of Bloom taxonomy that we call higher order thinking skill. This one is combinatorial thinking skill, the position there in the top level of the Bloom taxonomy. Now, what is the research-based learning? The previous one we are talking about the learning outcome, and now we are talking about the research-based learning, which is a model of teaching methodology. This is the syntaxis that we use so far. We develop a research group. So if you implement the research-based learning, of course, you should have a research group member. Like you implement the lesson study in the classroom, you should have a lesson study member. At least you have 2 or 3 teachers in team teaching and doing teaching together and open lesson together and invite people. See, this one almost similar with that. And also you should tabulate, you should identify and list what is the problem, an open problem arising from the RG open problem. And after that, bring the research result into a classroom. And students are encouraged to develop a problem-solving strategy in the classroom. So research-based learning actually bring your research result or other people result into a classroom. So teaching based on the result of the research, not teaching based on the textbook. Teaching not and based on the module, but teaching based on your research. I believe this one motivate a new innovation all the time. When you teach based on the research-based learning, if you teach based on the textbook, I believe you will not have an innovation every semester. I'm thinking that I believe the teacher, just like this teacher or lecturer, will memorize all the textbook content and teaching all the time in the same context. No different between semester to semester. But by using research-based learning, you are encouraged to bring your research into a classroom, and you recycling the research report, project report, research-based learning report in the classroom can be brought into the research group and can be a topic of interest in the supervision of the student thesis. So finally, with the student thesis, you have a joint research and joint publication. So there is a triple helix relation between a teacher and or a researcher or lecturer and a classroom, and as well as the final one in the research group member. So need the first one, you should establish the research group member. So we have also this kind of research group, and we have also already implement this research group in our faculty. Each program study consists of at least 3 research groups. So we have 15 program study, and then we have 3 times 15, 45 research group, and we encourage them to do research, to bring the research into a classroom. I believe this one. Now, when you have a technique, in this case, the technique is Super H anti-magic total graph under the application in the crypto system. And you have also a research-based learning, and you implement it in the classroom. I believe you can examine, you can explore the thinking process of your student in terms of the combinatorial thinking skill, of course, in our research step. So how does it work? How does it work? For example, here, on the student result under the research-based learning, we have Super H anti-magic total graph. The specific graph, we use a cycle of order 6 with 1 vertex connector, and we have 4 cycles here. We try to have a labeling. Yeah, labeling from 1 until the number of vertices, 1 to until number of vertices. And there is an encryption. We have using a special formula. It is just a very simple formula here. yi xi plus ki modulo 26, because 26 is according to the number of alphabets in our word, in English word. We have A, B, C, D until YZ. We have a 26 module. And for decryption, of course, it just inverse of xi plus ki. So we have decryption xi ym. I just give you an example. For example, here, just I'm finishing in 5 or 6 minutes later. We have a plain text FKIP UNEJ, for example. For example, you have word this one. By using binary tree, the previous slide I just already mentioned, and using text character, listing the character. Instead of that, we use the label of the graph. For example, here, FKIP unit. F is the position 5 in the alphabet. A, B, C, D, A, F. Yeah, for example. And we have KI here. KI here is according to this one. Is 1. And XI plus KI, of course, 6. And then YI is 6. XI is 5. KI is 1. 1 is from the label of vertices on the graph. Sorry, I just mentioned F. F, you should count from A as a 0. A is 0, B is 1, C is 3, 6 is a 4, and then F is 5, not 6. And then we have G. So finally, we just confirm the result of the addition is 6. 6 in the alphabetic order is G, because the modulo is 26, then start from 0, 1 to 25. Again, K. K is 10. In the alphabetic order, using numerical order. 0, 1, 2, 3 until. And I is 8. P is 15. U is 20. N is 13. A is 4. What is about 2, 9, 12, 14, 15, 3 is from the label of the vertices from here. And then we implement this one. And finally, we have this second of ciphertext, GMRBICHR. So the encryption process from plain text, FKIP unit, which is readable by human being. Now we have encryption. This is the result, GMD and so on. And conversely, if we decrypt, and finally we have FKIP unit. So this is the research working on our side, implementation of application of the graph theory, super H anti-magic total graph for encryption. But there is not only the algorithm of the encryption and decryption process. The result also is the level of the student thinking skill according to the combinatorial thinking skill. When we have the combinatorial problem and we try to split the indicator of the level 1, level 2, level 3, level 4, level 5, level 6, we consider, and finally we can level the student thinking level, the combinatorial thinking level. So once research of interest, you can have two paper, for example, a research process. The first one in the basic sciences process, in mathematical science process, and the second one in educational process, which is the learning outcome is the one target of the research. That is the higher order thinking skill. In this case is a combinatorial thinking skill. So we use a statistic to have this one. And also we use a spreadsheet. And finally, we have a distribution of the control class. For example, there are two classroom, experiment and control classroom. And you have percentage of the criteria. And finally, you can have a combinatorial thinking skill. So the conclusion is when you go further from combinatorial thinking, that is a pure mathematics, and then you implement in the classroom, and then you explore the higher order thinking skill process of your student, and then you can have the educational manuscript, for example. But if you go further with the combinatoric sites, and then you have a theorem, lemma, and everything, and then you have another paper which is pure mathematical aspect. If you develop the algorithm into a listing programming, and then you testing the accuracy, you testing the also the number of iteration, you testing the computational effort, you testing the error, which is error going to the error history also going down, due to the number of iteration increase. This is also part of the computational research. So I just giving a concluding remark of our presentation that sometimes we can do research in the parallel thing. So from the one research of interest can be split into several research. It depends on which perspective that you want to work on that research. So in our case, especially in the pandemic, we do not have many students come down to our lab. So we just restrict to the number of students in the laboratory. So also we have doing less about computational research in terms of testing in the computer. But in the student learning outcome, we can do more research because we can do using direct interaction platform, Zoom cloud meeting, for example, using Google Classroom, using also Google form to test our student. So it is possible. Everything can be done in the pandemic era. So especially this one, I derive the face portrait of the student using Google form as well to interview the student. And then finally we have this case. So I believe everything can be done. Even the COVID-19 outbreak is not finished yet, but we should move on. As a lecturer, we should create something and having a good joint research with people. And finally, we can conclude that the implementation of research-based learning can improve the student combinatorial thinking skill and developing a secure crypto system by using super H anti-magic total. And other, I believe, I don't want to read this again. You can read it, but the open problem might be in the future research. You can determine the student combinatorial thinking skill under the implementation of other based learning, and as well as analyzing the student combinatorial thinking skill by other scientific approach. So thank you very much again. As on behalf of the faculty, again, I appreciate the presence of Professor Adil and also Ramas and other invited speaker to share his and her knowledge in this conference. Assalamualaikum warahmatullahi wabarakatuh. Yes, giving back to moderator.
This previous presentation is about combinatory thinking process for education, and now we come to the Q&A sessions. I will give the opportunity to 3 participants. You can raise and you can use the raise hand feature on your screen, or you can type your question in the chat room. Any questions? No questions? Or you just
Coba di unmute. Mungkin mulai tadi tidak di unmute sehingga dia malu. Barangkali, coba. Semua partisipan, barangkali.
Sudah bisa otomatis.
Ya, saya kira cukup, moderator. Moderator, belum terdengar suaranya.
Okay. Last but not least, we will watch the presentation from Dr. Dwi Wahyuni. She is the chairwoman of Airku 2020, and she has a study about bioinsecticide and biolarvicide to fight dengue fever in Indonesia. And from and Dr. Dwi, time is yours.
Thank you, moderator. Good afternoon, ladies and gentlemen. I would like to present my research about produce a new bioinsecticide product of the toxin granular agent the Aedes aegypti larvae. Okay. My research program government by research. Now, this is very urgently needed a new bioinsecticide to agent Aedes aegypti larvae. During this abatement is the only insecticide that is used to agent mosquito larvae. Continuous use of chemical insecticides will cause resistance, resilience, environmental pollution, and human health. For this reason, research on new bioinsecticide is necessary. Indonesia requests investment new biopesticide. Agent Aedes aegypti specialist. My research started in 2003. This research was started in 2003. This research was started in 2003. Saya graduating doctor continuity of the dissertation. Start from the small to the high research field. This research is the final result of previous studies that success in option compound disease. Okay. Okay. My research, raw material my research, Srikaya sheet, and green petalin. Raw material are very important in the initial production stage in the real production of industrial scale. Raw material recruitment in commonly called raw material specification become the main basis in the selection and correction of raw material to be produced. The raw material in this study, in this picture, Srikayani and green better leaf. Srikayani and this better leaf. Okay, green better. Sirinjo. Okay. Okay, this is my raw material. Green better and Srikaya sheet. Okay. My raw material continuously. Okay, the crushing raw material that have been checked and declared to have passed the next step. And the raw material will be crushing of cancers that reduce the size of the raw material so that they will be supported during the next process. And the process of mechanic this raw material is crusher and grinding machine. This is crusher mechanic. Okay, and then after crushing is maceration. Maceration is immersion of raw material into again having cooled with a crusher. Immersion is done by using solvent or solvent that have been determined by researcher and has been tested in the laboratory scale by ethanol 70%. And immersion can be done by using macerasi. Come as in the following technical by using directly with the cup in the extractor machine. The immersion time is also adjusted to the result of previous studies with 6 until 10 days. 6 days until 10 days. And add to soaking maceration. Periodic star cleaning is also required for the protection of the soil. Active compound release from the shell for raw material. This is macerasi with ethanol 70%. 6 until 10 days. After macerasi is filtering. Filtering is done to separate the raw material fiber from solvent that already carry the active ingredient that is being shared. Whereas the extraction aims to extend that the solvent is converting started from the raw material fiber is done with a hydraulic press. This is filtering. Okay. Filtering process. And after filtering process is evaporation step. The evaporation step is the step to increase the viscosity or concentration of the extract produced from the distillator mechanic. Okay, distillator mechanic. And this is very important to maintain the temperature, stability, and frequency of standing. This is evaporation mechanic. Okay. And then after evaporation is mixing with process and supporting material with extract contain bacteria. Ingredient is carried on with a supermixer mechanism. Okay. When this mechanic a good level of homogeneity will be obtained. Supermixer uses double blend and high speed in the mixing process, so that in a short time and maximum result can be obtained. Okay. This is mixing process. Okay, and then after mixing process, this extraction drying state. The extraction drying state is carried always an oven that is working automatically. When this open a good drying process will be optional when the temperature has been set to be stable and automatic. So also with the required duration of 8 until 12 hours at the temperature of 40 degrees. This is extraction drying stage, process extraction drying. We open and result about extraction drying. Okay, next, after extraction, after drying, this is grinding activate. Okay, grinding. The process is carried out to regulate the size of the extract. About 40 size extract particle arranged by mechanic grinding or milling using a filter whose size has been adjusted to the size of the desired ground. Okay, this is process grinding. Okay, and then after grinding, packing. Okay, packing sachet aluminum foil. Packing is the main protective packing that will protect the produce from the effect of water on the influence or sunlight, which can affect produce quality stability in the long run. Okay. The choice of aluminum foil packing material is very important in of the size of the material density. Micron which will affect the durability of the produce. This is my produce. PUAA. This is the new PUAA design. My produce have hacking and have a published with number of published application 20 and 50. Okay. I think this is enough about my research. Thank you, Lord Moderator. Maybe any question or
Okay, thank you, Dr. Dwi, for your presentations. And I think the time is over. and we get to Master of Ceremony. Thank you very much and goodbye.
Okay, thank you very much for Dr. Diwahyuni and Mr. Adit. Thank you very much for the interesting presentation today for the last session of this keynote speaker, but this is not the least of our event. So after this we have a break for 40 minutes. And before we have a break for 40 minutes, I would like to announce some important announcement for all the participants. Could you please rename your name account of Zoom? You just add your room in front of your name. So the room and slash your name. So we can arrange and adjust for the other step in the parallel session. So could you please doing for us? So you can just add your room for presentation in front of your name. So the room slash and your name. Okay, so that's all for the announcement before we get back to our parallel sessions. So we have a break for 40 minutes. Thank you very much for all of the keynote speakers, and thank you very much for all the participants here. And we'll meet again in our parallel session. Thank you very much. Have a nice lunch.
Nggak jadi dibacakan itu tadi.
Dari sana diumumkan tadi. Mungkin dengan bahasa Indonesia juga. Saya
Terus dimulai jam berapa nih? 12. Dari jam berapa nih? Sekarang belum jam 12.
Jam
12 on time Pak. Di Arab dimulai jam 12. Ya. Bisa nggak jam 12? Sholatnya jam belum? Cukup nggak? Jam 12. Jam 12. Ya,
12.30.
For all the participants, now just the last. This is the last. So we will meet again at 12 o'clock after we pray Dhuhr prayer. So ya kita akan ketemu lagi di jam 12 tepat untuk memulai parallel session. That's all from us. Thank you very much.
paling cepat. 12.30 paling cepat.